The Earth is very flat.
What's going on, everybody? It is Thursday, June 3rd, 2021. This is Brandon, host of Brandon's Show. Hope everybody's doing good out there. We've got Ian Adams, Paul Cruikshank, YouTube, Dan Morris, Cleary, Bill G, Gadget Inspector, Enigma, Page 42, and Matrix Media, who was first. Nice job, Matrix. What's going on, guys? Anything exciting? Oh. Evening, Paul. All right. What do we got going on today? Not much. I see the news is all about Fauci and some interesting emails that came out. What a shock. What a shock that this guy was lying. Who could have guessed? Crazy. We might talk about that. I don't know. We got pretty deep into that stuff the other night, and I was a little bit worried. But it is gone pretty mainstream, so it doesn't seem like there should be anything to worry about. Anyway, got some people in Discord, and it kind of named this show Open Panel, Open Topic. I really didn't have anything top of mind to talk about, so I figured we'd just see what people wanted to talk about and go from there. So let's do that. What's up, guys?
What up, Brandon?
Hey.
What up?
What up? We've got FE.
Hey, man.
Hey, what's up, FE? Face One, Aaron, Geo, Jeremy, Matrix, and Rob. What's new, guys? Anything?
Not much.
No? Okay. Hey, Matrix Media J. Are you the Matrix? Is your name Matrix Media in YouTube too? Same guy,
Yeah.
right?
Yeah.
Okay. I thought so, but then I thought, well, it could be different, but that makes sense, I guess. Bill says the sound's good. Thanks, Bill. What's up, Will? Yeah, so you guys hear the shocking revelations about old Dr. Fauci?
What do you say?
You mean the same bullshit we already knew?
Yeah, that's it. Yeah, exactly. Who would have guessed that this guy is full of shit? Amazing. I've got this article that details what was in his emails. I guess they got his emails via FOIA request. The Washington Post, of all people, which makes me suspicious, and BuzzFeed.
There's a couple of reliable sources for you.
Yeah,
It's like those people. It's like they don't realize that they're only talking pieces, and eventually they're going to turn on you, right? Just like Bill Gates. Look what happened to his wife. His wife divorced him. Why? He's probably going through the same shit Dr. Fauci is going through right now.
Maybe. Why are they turning on this guy all of a sudden? It's Washington Post and BuzzFeed usually protect people that are in their little club. Why are they all of a sudden tearing this guy apart?
The thing is, everybody that's being used by the Democrats, they're all disposable. The only thing that's important to them is whatever nefarious plan they have planned. Everybody that's actually realizing the actual plan, they're disposable. They don't really care. They don't matter. Especially if you're in front, like on TV, you're a puppet.
Huh. This Fauci guy, he's a Democrat because he was hired by Trump. See, I knew when we were in that this guy was, well, it was confirmation that he's full of shit when Biden hired him and kept him around after Trump left office. And I was like, it's always a bad sign when they agree with each other. It's like, oh man, they're agreeing with each other. We're about to get really screwed. But whatever. I thought we'd talk about this for a minute. Just more confirmation that the best way to approach these things is with extreme skepticism of anything that the establishment tells us.
Contempt is the best approach.
Right? Here's one more confirmation of that. Not that we needed another one, but there seems to be some people around here who think that you can base your reality reliably on what the media and the powers that be in the world tell you. That is a mistake. So they're going back and forth. Now, this makes me wonder, too, what they're up to, because they're talking about where did this thing originate? Oh, why are they doing that? Why are they all of a sudden? Because they wouldn't even allow any discussion about this a few months back. Like, literally, if you brought this subject up, you were taken out, taken out of the public light or attacked immediately. And now it seems to be okay to talk about. Before it was a conspiracy theory, and now we're seeing it unfold. So what changed, and what are they up to? They need a fall guy or what? I don't know. But yeah, this is pretty weird. Perjury, does anybody actually believe that this guy's going to get in trouble for lying to Congress? No.
Yeah, he's gonna get the same treatment Epstein got. That same disappearing treatment. That same treatment. He's probably most likely gonna get.
Yeah. Going against what this guy says, mind you, would make you a science denier a few months back, might I remind everybody. So just think about that for a minute.
Well, science changes. It's like liquid. It flows. It's got to adjust for the times.
Yeah. And if you remember the other night when I asked Brenda, I said, so Brenda, if I wanted to get information about this, where would I get it? Well, just do an internet search. I said, okay, I did an internet search. Where do all these things came up. Now, which one do I read? Which one do I trust? Well, I'll bet you that a lot of those top results.
You got to go with your confirmation bias.
Yeah, whatever agrees with whatever you think. That's how you choose. Yep. Good point. They would have quoted this guy. No. I don't know. Anyway, so that's happening.
Sorry, what was in the emails? What did he come out and say, or what was in the emails, or what got discovered?
Here, let me.
It was supposedly the connection between him and Bill Gates, and him and every head of state. Pretty much everything that was displaying, that all the conspiracy theorists saw, every link, every bullshit that was telling us, that's what's coming out.
Let me read this. Why would he be concerned that Americans would? Okay, so they're talking about. It appears he was very concerned about people concluding that this thing may have been man-made, that it could have come out of a lab. So it says, why would he be concerned that Americans would conclude that? Possibly because Tony Fauci knew that he had funded these gain-of-function experiments at the very same laboratory. So these emails apparently show that he was involved with funding research that some people were pointing to as the possible origin for this very thing.
Oh.
Yeah.
Bullshit, Brandon. You're telling me that the COVID did not come from a lab in China?
I don't know, man. But if they're saying it did now, if they're trying to make us think it did, now I don't know. I don't know what to believe. Does it matter? Are we ever actually going to know whether it did or not? Is it possible?
I think it definitely matters. It definitely matters. I mean, we'll probably never know. You're right on that part, but it does matter if this was introduced to humanity naturally or, you know, by a man-made source.
Yeah,
I think
maybe.
we do know. I think we know.
They put the world in.
I never think we're gonna get it confirmed though, but we do know. We do know.
I mean, this was the biggest form of. I don't even know. They held the whole world hostage with this. Whoever introduced this, you know, this was worse than anything that anyone's ever done in history. How many people died from this supposedly? How many people are still dying?
I was going to say, it's also possible that whether behind closed doors, Fauci started to go off script. And so what they do is they run down and demean and destroy somebody before he gets a chance to actually go off script. So,
Good point. Good point. They do that. They will ruin your name.
Yeah, your reputation, exactly. Yeah. So whether his conscience got the better of him or whatever, that someone had leverage on him, who knows? But if he was going to start to not play the game properly, then they just destroy him publicly so that no one will listen to him in future.
Yeah, they only fuck you up if you go against the grain. If you're going along with the orders and what they say to do and what they want to happen, you're good. But as soon as you go against it, you're fucked.
Yeah.
Hmm.
Just a conspiracy theory of mine.
You crazy conspiracy theorist.
Right. But yeah, like Brandon said, if 1 week ago, if you'd gone against Fauci, you were a science denier. 1 week ago, if you said there were UFOs, you were a tinfoil hat lunatic. You see, like the internet media, your position in the world changes day to day, week to week, whether you're on board with everybody or whether you're a nutcase. You know, you just got to keep up with the bouncing ball as it moves along.
Yeah.
Yeah. I don't know. I don't trust anything that comes out of the Washington Post or BuzzFeed either, because they are highly suspect of being
any
Mockingbird
mainstream
press.
Yeah, any mainstream media source at this point. I mean, they're mostly owned by, you know, very few groups owns these media organizations. I mean, they probably got their hands in the pockets of even the little guys at this point, you know, the little ones on the internet where you find.
Yeah.
You know what? In relation to that, Jeremy, you know what I've noticed lately with YouTubers? You guys remember how they used to cut to commercials? Well, now people just put the product in front of the TV and they casually start talking about it like in the Truman Show. You guys remember? I've caught a couple of YouTubers doing that. That seems to be the new way of the new television, like the new advertisement kind of way. They just pick up any product and start talking about it like if they really use it in real life.
Oh, product placement. Yeah, they've been doing that for a while. They did that in movies and TV too. Or like they have
you want your car. You want your car in the new. Oh, go ahead.
They have all the anchors like drinking Coke during the news show or whatever. Yeah, they do that stuff.
Yeah, you want your car in the next Fast and Furious. You know, you got to pay up. You want them to drink Pepsi instead of Coke. You know, you're gonna have to pay up. Otherwise, they'll just drink some generic brand that no one heard of.
Yeah, and the Defense Department and the intelligence agencies and foreign governments, China, all have their fingers in that too, trying to, you know, manipulate people through controlling the content that we see. It's nothing new. There's propaganda, constant barrage of propaganda that comes at us. And one thing that's always in that propaganda is the globe. The globe is always in there
some people probably do put products in their YouTube videos because they generally do like them and, you know, want to promote them maybe for nothing just because it's a good product. But when you're talking about mainstream shit, movies, television shows, yeah, they're all getting paid.
Yeah. Oh yeah. For sure.
Well, that was some hell of a propaganda thing they put in that Sesame Street thing I sent you.
Yeah, let me see if I can bring that up. That was pretty funny. Sesame Street trying to tell us something.
Yeah, that's a weird place to put that stuff. Right on the fiction shelf.
It is a little strange. Think, well, did they do that as decorations
This
or
area is
what?
filled with books about pretend people.
I don't know. I don't know.
Right, Grover, this is the fiction
These people
section.
always tell us.
Fiction
Remember,
means
these
it's a made-up story.
elites. It's some weird rule they have where they always have to like inadvertently tell you what's going on. You know.
Right. There it is, guys. Globe debunked. The Globe is in the fiction section. Done. All done. PBS. Our job here is finished.
Got it down.
What do you guys got to say to that? Nothing. Nothing. Show us a clip like this where the Globe is in the nonfiction section. I bet you can't find one. Yeah, that's a pretty funny clip. I'll put a link to that in there. Anybody wants that? Jeremy, how much time a day do you spend on TikTok?
I mean, I don't know, at least a half an hour, an hour. I get flooded with conspiracy shit. Like, I've never seen so much flat earth stuff than on TikTok. Like, they just, it's like YouTube before YouTube changed the algorithm.
Yeah.
They're just pumping flat earth shit. Yeah, it's like that. Just wait, because they'll probably do what YouTube did, fix the algorithm, and then no one will be getting any flat earth shit, so.
Right. Yeah. They'll fix the glitch. Is it just these short little clips like that? I haven't spent too much time on there. That's on TikTok, or?
I mean, some of the flat earthers on there are live streaming. Well, it's mostly short clips, but I seen Witsit on there 2 days ago.
Oh, okay. He's live streaming on TikTok, huh?
No, it was just a little clip.
Oh, a little clip of him.
Yeah, a little clip. I hear David Weiss. David Weiss is on it. David Weiss was debating like kill a priest from the Wu-Tang peoples.
Is that what that was? I saw that. I didn't know who that guy was.
Kill a priest. He was one of the better people that came out of Wu-Tang that wasn't an official Wu-Tang member. So.
So David Weiss is a member of Wu-Tang now. Well, that's cool. Killer Priest podcast. Never listened to it. Well, did you watch it?
I mean, and Wu-Tang. No, I just caught a couple minutes of it. Wu-Tang used to put a lot of heliocentric bars in their rhymes. So, no, go ahead. So yeah, they're hardcore Glovers, Wu-Tang.
Did Dave? I wonder if Dave turned them.
I don't know.
I like his appearances. He does a good job talking to these people because he seems to always be the one who gets invited to go talk to people. I don't know if he like bugs them until they invite him to come talk, or if he just like I don't know how he does it, but he does a good job. He was on Anthony Cumia a couple times. I saw him. And there's another show on that channel. These guys were just fucking joking around the whole time. Dave did a good job of keeping us cool. But sometimes when he does it, he starts talking about other stuff. I'm like, no, don't start talking about that. That's too much. That's too much for people just hearing about flat Earth. Don't bring up giants or, whatever. Just keep it like, keep it to the.
Yeah, seriously, man. That's why That's why Kent Hovind never got into flat Earth. He's like, dude, I'm already killing him with this evolution thing. This is a big hassle. Like, I can't start talking about flat Earth now. You know what I'm
Yeah,
saying?
no
Just
doubt.
stick to your topic, man. Don't bring too much, crazy ideas into it at once.
Right. Yeah. And if he's got a good thing going with evolution, he's taken seriously within that community, then you start talking about flat Earth. Well, that all goes away because then they'll just attack you on being a flat earther. Eventually,
Yeah.
hopefully, the Overton window will be shifted to the point where people won't think automatically that you're a lunatic if you're a flat earther. And it has for some people. I'm not saying everybody thinks that, but there's
That
still
is the
that.
general consensus, though. If you mention flat Earth on the street, as soon as you mention flat Earth, people start looking at you funny.
Yeah, because I tell some people in my private life, I don't go around and advertise it. Like people I work with, or say I meet hanging out with my dad, and I meet his friends or something. I don't sit there and go, oh yeah, I'm a flat earther, and tell them all about it or anything like that. I just don't push it on people at all.
Yeah.
But if it comes up, like, yeah, I'm a flat earther. Yeah. And then it's interesting.
It's funny watching normal people. It's funny watching normal people trying to be like, yeah, but what about this? What about that? Because they have no idea what, It's like when a Glober first comes into this arena and they think they've got, they've got all of science and all of everyone's on their side, and then we just fucking destroy their arguments.
Yeah, most people think they know science and all about the heliocentric model because they watched like fucking a PBS special one time or something. Like before I got into flat Earth, I didn't know shit about the globe. I couldn't tell you how big the Earth is or how far away the sun was. I didn't know any of that shit.
Really? You didn't know the sun was 93 million miles? That's because you didn't listen to Wu-Tang enough.
I guess so. I did not realize that Wu-Tang was throwing education in there.
They are hardcore Glovers, bro. I'm telling you.
Really? Huh.
Yeah. They're not avidly, well, I mean, I guess they are now, but before that Kill the Priest thing, they weren't like avidly debating it or anything, but they just have a lot of heliocentric raps.
That'd be funny if they joined the community and became like part of Jem's Trolls or something.
Yo, there's a good battle rapper that's actually, I think he's a flat earther. I don't know. He drops a lot of flat earth bars. He's called Daylight.
Who is it?
It's a guy called Daylight. He's a huge weirdo. He's a really good battle rapper. He's got some good raps, but he drops a lot of fucking flat earth shit.
He's a huge weirdo. That's hilarious.
Huge weirdo.
What's his name? Daylight?
Daylyt. I'll send you a couple links later. Yeah, I'll send you a couple links later.
Oops, I totally butchered.
Couple freestyles he did. Got a lot of. He talks about wrong Earth circumferences and just a whole bunch of stuff. About the helium.
I found him. Yeah. Okay. Daylight battle rap. Oh, I see him. He's got face tattoos.
Yeah. Oh, he's a huge weirdo. I think he took a shit on stage once. I don't know if he shit or not. It's still up for debate, but he's definitely a big weirdo.
There's a big controversy over whether he took it.
Yeah, Eminem did a thing. Eminem put on a big battle rap show one time. Joe Buttons was there. A whole bunch of people were there, and I don't know. At the end of Daylight's rounds, he was definitely trying to take a shit. I don't know if he did or not. I didn't see any doo-doo. I don't know.
Oh, man. Huh. Well, I hope they get to the bottom of that one. Gleam says, Daylight is Don, but why you forgetting Dave's son? Is that a rap?
I don't know what that means.
I think that was a rap. I'm not sure, though. Gleam's got some skills too. If anybody out there doesn't know, go check out Gleam's music. It's pretty cool. In fact, let me see if I can bring it up. We'll give Gleam a plug here. what is it? Adjust your brightness. I'm trying to remember the name of that song. Now I'm butchering it. Oh, I will bring it up, Gleam. I won't leave it like that. Anyway, so what's going on in flat Earth world? You been hanging out over at Gems, or anybody got a new proof they want to talk about, or something they've been thinking about?
No.
So open
No.
topic. So this is anybody's chance. There's no annoying Globers in here right now trying to call us idiots.
I actually left. I left
I'm
Gems.
here.
I left. Oh, go ahead.
Hello, Brandon. Hello, Jeremy.
Who's that?
Yeah, I'm Crow.
Hang on.
Oh, I spoke too soon. No, just kidding. Hey, what's up, Crow?
Yeah, I'm fine. You know, I'm a hardcore Glober, but you've just shown something here that fiction. So yeah, I get it.
So you're
Nothing more to say.
exactly. See, Crow gets it. Crow's on
Yeah.
our side now. If he gets it, you guys can get it too. Pretty solid, right?
Exactly.
How you doing, man? You haven't been around for a while.
Well, I had retired like almost a year ago, or even more. So I had a lot of time. I was around, but then I had another job, so kind of quit.
Oh, you quit flat earthing or
Yeah,
globing?
both.
All right.
What's the matter, man? Ain't paying the Globe chills enough? You got to go get a real job.
Yeah, exactly. Paycheck is not enough from them. NASA's getting poor.
Yeah, man.
So you've been out kind of listening in, or have you been just kind of completely checked out of the whole scene?
No, almost totally checked out. Like the first show I watched for you was yesterday. That's for over 3 months or something.
We had a good show yesterday.
Yeah,
Come on.
I like that idea of the LIGO and some canal beside it. I guess I understand it, and it looks good.
The beauty of
You
that
were listening
is,
to that whole exchange there, because I got to get something straight. When we were going back and forth, and I was getting annoyed with Brian, and Brian was getting annoyed with me. Was Brian right that whole time when I was insisting that I needed to explain it and show the diagram?
Brian was right the whole time, bro.
I don't believe this. I'm
He
gonna go back
he
and
was,
listen to it.
He was right the whole time.
I think he was wanting a water level or something like that to use. I forgot what was.
No, we were talking about, are you going to be able to tell, no matter where the tangent is, are you going to be able to tell whether it's the water curving or LIGO not being straight? Right? Is that what you're talking about, Brandon?
Yeah.
That part?
Yeah.
Yeah, Brian was right on that the whole time.
So
yeah.
he was saying,
and we weren't letting him
okay.
talk either. I'm like, Brian, just chill, bro, for a minute. Just chill.
Shit. All right. Shout out, Brian. I guess you were right the whole time, and I was holding us back. But back to you being away from it for so long, Crow. So you were out of the whole thing for so long. I did that before too. Did your thinking about things change at all over that time?
It's my opinion is still the same. It's declining. The arguments are declining.
For who? Just in general, or for a certain side, or?
No, for the flat Earth.
Oh God.
No. You mean you've gotten more zealous and globe loving since you've been.
No, I didn't say that. I didn't say there's better proof that I've seen from the globe side. I'm just saying that there's weak arguments. Like I've seen the last shows that I witnessed was kind of arguments about the Bev tests, and will it really expose if it's flat or not? And I've seen a lot of argument from Gleam, who's there, and what else? The guy from Australia. They were trying to speak. This is not going to work. This is not going to expose if it's globe or not. So I've seen that you guys are doing good job in picking on what's not right and what's wrong. And then I was involved like for 2 months about basics of geometry, and I was so exhausted, so I cannot lift. That's why.
Okay. Interesting.
The geometry thing's exhausting with your spherical geometry, huh? You can't figure out what a straight line is or what's not a straight line. I know, it's crazy.
No, it's even more basic than that.
Brandon,
Oh, we're
salute
doing
if
it.
you can hear me. Hello, check. One.
Hey,
Can you hear me?
Gleam, what's going on,
What
man?
up, Indio? Oh,
Yeah,
that's
salute.
Gleam. What up, Gleam?
Now, salute for playing that. But either way, I have to explain. No, Dave Murphy. You know Dave Murphy, flat earther?
Oh, yeah, Dave Murphy. Yeah,
black,
yeah.
Is he a black guy?
Yeah.
Is he a black guy?
Yeah. His son is a top UK battle rapper who literally.
Ooh, what's his name?
It's Koj. Charlie
Oh,
Oscar, Juliet, Alpha Yankee.
Well,
Never heard of him. What's he in? Don't Flop?
He was,
Is
and
that
then moved
underground media
over.
guy?
Sorry?
I
He's
don't
the
know.
guy, you would have known of him, but he's the guy who was in uni, lad, he's in a pub and he's up against a professor. Flat Earther versus Professor. You must have seen it all,
I don't think so.
where they
I
go
watched
through
a lot
like-
of Don't Flop too.
No, I'm talking the Unilad thing where they say Flat Earther goes up against a professor, and they're sat there. The professor's got curly mad hair, and they go through all 5 points or something.
No, I didn't
And
know.
that's him,
Yeah.
Koj. That is him, and he is a wicked battle rapper. Sorry, can't hear you there, Travis, brother. Salute though, man.
Salute to you. I was just saying, yeah, I saw that.
Yeah. Koj is good, but as well, Daylight is a super don. Daylight.
Oh yeah, he's a beast.
He's
He does.
mad.
Did you ever hear? Did you hear his flat Earth bars? If you check his I-95 freestyler,
Yeah.
a couple of his freestyles, yeah, he spits the flat Earth.
But
Flat
his
Earth,
history. If anyone keeps up with battle rap and doesn't know who Daylight is, his history is embedded in battle rap.
What do you think? Did he shit or not?
Of course he did. That
He
is
did?
Daylight. That
I
is
don't
Daylight.
know, man.
Who-
I didn't see
who
no
has-
shit, bro.
Yeah, who has tattoos on their face like that? And he's made a career of it. He's literally come out all dressed as a. I think he was dressed as a sort of like Count Dracula or something like that. He's come right the way out and told everyone to pee off, and then literally walked off stage and didn't do the battle. He
Earth.
serious.
Yeah.
He does it. He does it for the attention, and that's exactly what he got. And it's a marketing plan, a gimmick marketing plan, but it made him. Daylight is words though. He's a wordsmith.
Yeah, he's
Definitely.
good. Good, man.
Gleam, have you ever thought of creating a did he or didn't he take a shit on stage controversy to kind of get yourself some more press?
Nah, because anyone who thinks that or who's seen Daylight's history would know that he would have done it without a blink of an eye. He don't care.
Oh yeah, he would have done it, but did he though?
Yeah,
Did he? I didn't see no proof.
I don't actually care. It's funny as hell. The whole thing of that is what a marketing plan. And it didn't stop at that. You think that's extreme? That is one of the normal ones from him. He done some mad stuff, and seriously, it's jaw dropping. It's jaw dropping, and messed up the company a little bit from a battle perspective. But he don't care. He marketed him, and it worked.
Yeah.
So you do battle raps or anything like that? You get involved in that stuff? Gleam?
I used to teach it for about 10 years.
You taught how to do battle raps. Wow.
How to rhyme? Yeah. In my local area, in my sort of like county, let's say, I've probably got about 40 people, 40 youngsters that I've taught that are in their 20s now, still doing it.
I think the best guy you got over there is Lunar C. He's probably your best in the UK.
See, you got to understand the eras. Now, Lunacy will immediately tell you if you're on about a rapper's rapper. Lunacy will immediately tell you that Chester P is 10 times the man he could ever be. at freestyle, at battling, and at rhyming, at rapping. But yeah, Lunacy is number one because he won all the battles, and he is funny as. Boop. But anyway, back to Flat Earth.
Back to Flat Earth. So did you happen to catch yesterday's show, our little experiment that we want to do with LIGO?
No, I did hear dribs and drabs. I come in and out.
Yeah, I mean, it's
I was
pretty
coding
basic.
And you were on in the background.
If
But
Brian
yeah, go on.
it was here,
Explain
he could
it.
explain it a lot better than me, but I'll give it a try. Essentially just using LIGO, actually the concrete enclosure, assuming that is a straight line, and measuring the water level of the canal that's next to it against that straight line, seeing if there's any divergence.
We've been looking for a straight line this whole time, and we got one at LIGO.
We found a straight line.
Supposedly.
Supposedly.
Yeah, they won't
I don't
give you
even think-
anywhere near it.
You don't think they'll let us in there?
Nah, not to just wander about. You'll have guards come out.
All we need to do is get to the canal.
I don't think so.
That's
dude.
beside it.
The
I haven't
canal's
investigated
on
it, to be honest, but
it's part of the property, I think. I mean, it's right next to that arm. If they're not going to let us by the arm, I don't think they're going to let us in the canal, personally.
yeah, if you think there's what is it, a 1.3 billion project or something, it's going to be armed to the teeth.
Yeah.
And especially put it this way, LIGO, I don't know whether you knew this, but LIGO works by filtration, sound filtration. So obviously it's the disturbance of light, but what they have to cut out of that is that disturbance, that minute disturbance, whatever it was. I think it was a fraction of a hair, a tenth of a hair or something that the disturbance was. In order to grab that, you need to filter out every single truck within the X amount of radius miles. You need to filter out every single footstep, every single sneeze, every single lightning, thunder, which they didn't if you investigate the first one. But yeah, so they filter out everything, and what you're left with is that raw signal of the disturbance. So if they want to cut down on noise and people messing about, they're not going to have anyone around for X amount of miles.
That doesn't seem
Definitely.
possible.
Yeah, I don't think it will be practical. It's a big area, and it's a very, very, very practical experiment if you would allow to something like that. Yeah, definitely. If you could find something out on common land.
Even people.
Well, I think we should still try. No, I meant it doesn't seem possible that you could filter out all the noise for miles around and everything you need to filter out.
I swear to God, that is how it's done. And if you look to, there's a guy, a particle physicist, can't remember his name now, I'll have to look it up. But if you look up, he'd done a presentation in CERN, Summit Jackson. There we go. It just sprung to me there. Summit Jackson, maybe Kevin Jackson. And it's all in English, and he literally goes through an hour of how they do the filters and how LIGO collaborated with each other to force the first detection. Because
sorry, go ahead.
Their filters purposefully let through the exact frequency they was trying to detect.
Even the
That's
people.
wow, amazing, huh?
Yeah, but the second one, third one, they reckon we accounted for this. So
Even the people that work in the same field as the people that work at LIGO say you just have to trust them. Like, you just have to trust that they're doing what they're saying they're doing there.
Let me see.
Speaking of what they're doing there,
was it all noise?
You probably have a pretty good grasp on it, Gleam. What the heck are they doing there?
Measuring disturbances in light. That's all I can basically tell you. That's the simplest overview. If you put, it's an interferometer. If you fire light down a piece of glass, like fiber optic, from one arm to the other, if something hits you at an angle or something hits you, I mean, to go through space-time and the bending of space-time is that effect is too mad. But if something hits you, let's say an electrical burst, a massive electrical cloud of energy hits you, solar energy from the sun or something, then LIGO will have an effect, or that will have an effect on LIGO. But I'll find you this article that goes through, and it's got the full link to the actual video. It's in the Forbes magazine. It was it all just noise? Independent analysis cast doubt on LIGO's detection. But as I say, this was the very first one. Only.
Gotcha.
They're basically measuring something 1/10,000th the width of a proton, I think they say. That's what their claim is.
Yeah, it is this very, very slight disturbance, and it is, I don't know, put it this way, if you look at the funding of LIGO, what it done is it set up first off, within the first 6 months or something, it achieved what its original purpose was, to do something, to detect something. It wasn't the actual detection of the gravitational waves, but it was to do something, and they managed to achieve that. They then shut down for about 6 months or something to upgrade it, because they got additional funding for doing that. Then what happened is that their next mission was to detect gravitational waves. Took them a year or so to do that. Once they detected it, they shut down and upgraded again and got more funding. So it's a series of kind of like this is what this Andrew Jackson guy was explaining, that they're kind of forcing the detection to enable the upgrade for taxpayers' money to all get plowed into this project for it to then become a big thing.
Facilities that detected the same thing at the same time.
Yeah, it was two. It was the Hansford and the LIGO. They work in combination.
They detected the same. They had the same reading at the same time. Is that what you're saying?
Yeah, and that's what this Andrew Jackson says, is that what they didn't do is filter out thunderclouds, and there was a massive, huge thunderstorm directly in between the two sensors at the same time, and there was not conclusive evidence that was filtered.
Well,
there was no filter for that particular thing.
So they've never detected a gravitational wave before. Like we've never studied a gravitational wave. This was supposedly the first actual detection of one, correct?
Yeah.
That's what they say. How would we know if it was a gravitational wave?
It's the old to do with, well, it's predicted by the theory.
Okay. All right. Gotcha.
That's all you got to fall back on. That's the only thing you can.
I gotcha. It was predicted. All right. Our mathematical model says we should detect this. Oh, we detected
so
this.
Therefore, when we detect it, it confirms the model is true and we're on the right path.
Yeah, it's the equivalent of like looking at a clock on a wall. No one's ever seen behind the clock, and I say it's little magical elves making the hands turn. And then if I predict the big hand to land on the 12, boom, there's your little magical elves. Because I predicted it.
Yeah, there's one awesome observation though. I know I've told you about this one, Jeremy, but remember in what was it? August of 2017, the same day of the solar eclipse. On that same day, they had a detection at LIGO, and then received one over in Europe as well. And so they were somewhat confident it was a gravitational wave, and decided to try and triangulate the position of where this was coming from, because it was a fairly large one. And when they did this,
how'd they triangulate it?
Well, based on the timing of when it was received at both of the locations in Europe and the United States.
Yeah.
And they didn't get an
How does
exact
time give you? What's up?
Yeah. Go ahead, man.
No, I was gonna say, how does time give you a
the time
way to
difference.
triangulate something?
Yeah, the time difference. So yeah, so they can tell which direction it was coming from.
How does time give you a direction?
Well, if it was coming from the opposite direction, so if it's coming from the direction that would have been the opposite side of the United States, it would have hit the United States first, and then Europe first. You know what I mean? So the timing of the positions, knowing that it's traveling at the speed of light, is going to give them a general direction of where to look for this thing. And
so they knew So this thing's traveling at the speed of light, and they knew when it hit the one in Europe and when it hit the one in America first.
Yeah,
when this thing traveling at the speed of light.
Whichever one it hit first. I'm pretty sure it was one in America that hit first. But yeah, whichever one it hit first, they used the timing of when it was received there to try and locate that in the sky. Yeah. And when
Wait, are they saying the same wave? Like one wave traveled through both of them? The same wave?
Yeah, the same reading, the same
I posted two videos in the chat that kind of explains what happened.
And the amazing thing is that they told everyone in the world about this, told all the amateur satellites and telescopes that there was something in the sky to look out for, maybe some explosion. And I forget how far after, I think maybe a couple hours, someone located in that position. There was a kilonova, which is was the cause of two neutron stars colliding, which is exactly what the gravitational wave had measured. So they had measured it, and they had went and looked and saw the exact event that they were measuring.
All right, so I'm going to bring you and Brandon in the field, blindfold you both, and I'm going to throw a baseball at you first, and then Brandon, and I'm going to hit you both, and then you guys triangulate of where I am. You think that's possible?
Yeah, I don't think that people at LIGO are blindfolded, so whenever they get measurements, they
can't see the baseball.
Yeah, but they know what time exactly it was received there. So
I know. Yeah, I'll give you guys.
If we both had stopwatches,
I'll give you stopwatches. Yeah.
Yeah, and then we could press it exactly the moment where it hit us.
Yeah. That's fine.
We should be able to locate where you were if it was the same ball.
No,
you can't sync two clocks, by the way. Not precisely.
This guy. Oh my god.
Oh, wait, I'm still trying to figure it out. Man. So a gravitational wave is a tiny little itsy bitsy thing, supposedly, right?
I wouldn't say that. I mean, it's a wave, so I mean, I don't know if the size matters. I think it matters the amount of disturbance it's going to do.
It's the product of space-time. It's length contraction and time dilation hitting from a merge.
Okay.
With two gravitational wells, basically creating.
So what do you think about them being able to predict a supernova, Flame? It all checks out, and LIGO's legit.
Depends what your interpretation of the supernova is.
Just a light in the sky. Let's say it's just a light in the sky.
I mean, put it this way: the whole theory of length contraction specifically is ad hoc. Admittedly by Lorentz himself, and it's based on an electron, on how electrons' motion is, where the faster it gets, the smaller it will get, or the more concentrated, let's say, the more energized. And he admits himself it was completely ad hoc. He's just added the theory in as a necessity to the speed of light being fixed, and also time dilation. And then matching it up, his transforms then created or become the basis of space-time. And that's what this is. This is a disturbance in the space-time.
I think this is all a cover story for wanting to build a 2.5 mile long straight edge so they could measure the shape of the Earth. That's my theory. I don't know. I get it. So they think they're going to find they detect these gravitational waves, and they think they have. I don't know. It seems very precarious to me as an outsider looking in. What does that get us, by the way, if we can detect these gravitational waves?
Nothing. Absolutely nothing. Nothing at all. Nothing at all.
Go ahead.
Anything in cosmology will not produce any practical. Anything to do with black holes will never produce any practical purpose on Earth.
Okay.
You'll never be able to harness any such energy or reproduce or do anything at that scale that it's supposed to be.
There's no
It's
practical development, nothing applied that
No,
came out of detecting the gravitational wave.
nothing at all.
Okay, it's just
Apart
science, I guess.
apart from confirmation of the current theory, which has been confirmed to be wrong,
Right.
and literally a new line of investigation, let's say, to understand how often these happen and where they happen, what direction they're coming from, this, that, and the other. And yeah, a new line of investigation for a mathematical framework. There we go. That will help us in looking at the sky.
Okay.
But we won't be able to make an engine out of black hole science or anything like that ever. Never in our lifetime, ever.
So you got nothing, Kosho.
Bill is very mad at you, Gleam.
I didn't
He's
say
yelling
anything.
at you.
I didn't say anything, Jeremy. I mean, if you're asking me the same question, man, I mean, first of all, it was a unique event because it was the first time that we were able to co-witness something occurring in the cosmos like this. Whereas we could hear something occurring at the same time as seeing it occur. Like we could feel the vibrations and also witness the light, see it visually. So, and I mean,
Ooh.
I don't know why you, because he also said the same thing that it's confirming this model, this theory of
Tell us more,
of the
Kosho.
universe. That's kind of a big deal, answering the questions of what, of the biggest answers of, what is everything and what forms everything and all this kind of stuff. Those are kind of important questions to answer. I mean, if you want to
For what?
forward.
Hey,
Or move forward where?
Exactly. Perfect question. For what?
All sorts of things. I mean, the time dilation, and which is part of Einstein's theories of relativity. They allow things for like GPS to work, things like that. Things that are very
But that's already working.
useful to all of us. Yeah, exactly. It's already working now. It's working for us now.
Can I
because we
barge
understand
in?
these theories. We're confirming
I'd
these
like to-
theories. This same theory.
Kosho, how much
is that
thought?
Brian?
If you, hey, buddy, how you doing, man? I heard Kosho, man. I just had a couple things come to mind, man. If you don't mind, I just got a couple questions for Kosho, man.
Okay.
Like, how much thought have you really put into all this shit? Like, with this gravity. So if so you think that there's planets or stars with they can't even compress water, not even any at all. Okay, with none of the power on Earth, and you think that there's stars like quasars and shit like that, much less black holes. How much thought have you put into that?
Plenty of thought, sure.
Like, wouldn't you, if you ever thought about it, man, like a planet, let's say a planet with like 3 times as much gravity on Earth, wouldn't it have like 3 times as much buoyancy also? So they say the pressure on Earth, we don't really feel it because it's coming from all directions and all that. So how would buoyancy work then? Would buoyancy be 3 times stronger on a planet with 3 times as much gravity? And how would speed go? How much thought have you really put into all this shit? You just buy
Those
their
aren't
stories?
very complicated thoughts. I mean, the buoyancy would be a result of the weight of whatever medium it is and gravity. So,
Right.
something like Jupiter, which is like a fluid, almost the whole planet is a fluid. Depending on how much less something weighed that was below how much further down the surface, that would determine the buoyancy more so than just the amount of gravity that the whole planet has.
Have you ever looked up how much hydrogen it takes to equal 1 pound? Do you know how big
you mean
Jupiter
this
would have to
gaseous-
be to have
you mean this
more gravity
gaseous-
than Earth?
Yeah, I mean, I guess it depends on how much you packed it in, right?
Look, let me recommend before I just question these things instead of blindly accepting them, and ask these, outside the box questions and look into it. Look how much hydrogen it takes to make a pound. Okay, it doesn't make a pound, bro. It's lighter than air. Okay, it'll never make a pound. Okay, and but ask some of these outside the box. Ask some of these outside the box questions, man, and look into them. These aren't questions you're gonna get answers to on Google or anything like that, man. But ask the real questions that are outside the script, man, and man, you'll come up with some conclusions, man. You'll hear people like just blurting shit out to try and give you answers that just match their model, even though they don't really know the answers, man. That's what we get a lot of, man. I'm just telling you, man.
Can I just say that answer is
Brian.
Newton's universal law, which is 6.67, not 9.98.
Well, Brian, you know they believe that if you can, a spoon of stardust weighs more than what? The Earth, or I don't know how much. And people believe stuff like that. So
yeah, exactly. And we can't even compress water, even at all. Any liquid.
there's a point where like it's too much, man. I think there's a point where it's too much, and these people need to realize that. I don't know.
Right,
how...
gravity. Exactly, I'm with you. Gravity's such a weak force, and even with gravity and all the power we've got on Earth, we can't compress liquid even at all. How can they conceive realistically a planet with like 3 times, or a neutron star with a tablespoon weighing 100 tons or some shit? It's just, it goes against common sense. It's insanity, man.
If you say so. You know, neutrons, they don't have electric charge. So unlike the proton and the electron, they don't repel. You know, it's not going to repel itself, and it's not going to form in the way an atom's going to form. So you can pack neutrons in a lot tighter than you can, the atoms in their nucleus. Pretty spacious.
Okay. Well, how tight do you have to pack hydrogen before it doesn't float?
I mean, if it's in a tank, any tank at all, if the tank is empty, and you add hydrogen to the tank and weigh it again, it's going to weigh more. So if you want a pound of hydrogen...
Tosho, bro, let me stop you. The sun ain't a tank. Stars ain't tanks, bro. I'm asking you out in the vacuum, and the vacuum of space, the near perfect vacuum of space, how much hydrogen would it take to even be lighter than anything? If it's the lightest thing out there, how would it even compress in a vacuum like that? It doesn't, bro. These are questions that there's no answer to, man. I just like listening to y'all blurt shit out and to try and adhere to your model, bro. Don't do it. Just say I don't know.
It's a pretty obvious answer, though. It's like somebody brought up Newton's law, universal law of gravitation. You use this law. If you have some volume of hydrogen, you know how much mass of hydrogen.
Doesn't there have to be an M2, bro?
You can determine the gravitational attraction it's going to have.
You say that, but there's M1 and M2. So what? Hydrogen times hydrogen over distance squared when there's no fucking distance. You got to have an M1 and an M2 to adhere to that, bro. Right? I'm talking about like a star forming and shit. Bro, you're falling back on your equations, but they're not going to bail you out, bro.
Yeah. First of all, you don't have to use Newton's law. If you use Newton's law, you can still do that equation. Okay? If you want to imagine the entire mass of this, whatever it is, this gaseous hydrogen existing wherever, you can use the entire mass of it, and you can use some, maybe the hydrogen at the very extent of the surface of this blob. You can determine the attraction the center of mass is going to have to that outside. Or you can use Einstein's equations where there isn't a limit.
Yeah, about to say that's not Newton's law. M1 times M2 over R squared is not Newton's law, bro. Newton's law.
Yeah, M1 times M2
that's the inverse.
times G divided by the distance squared is Newton's universal law of gravitation.
I mean, Newton's, man. I mean, I have my personal doubts about that, but yeah, it's said to be Newton. Right on that.
We got a super chat from JQ. Makes the observation that I think is pretty interesting. Ever notice that every single globe proof involves some impossible tiny measurement?
Yeah,
absolutely.
Great scale negator.
I just wanted to add something on to the last thing they were talking about with gold. They're actually having a problem of wondering how did all this gold get here. Their model doesn't account for the massive amount of gold that we have here on Earth.
Well, there's a lot of heavier elements that there's not really a clear answer on. You know, the answer
it doesn't fit your model. Yeah, it doesn't
Well,
fit
it's
your
not that it doesn't
model
fit the
though.
model. It's not yet explained. Because not everything in the world
No.
is explained yet.
The
There's
massive
people
amount of
investigating things to come to the answers.
no. The massive amount of
Investigating or
gold.
making shit up, right? Investigating or
the
making shit up to fit your narrative. That's what you guys do.
No, the massive amount of gold doesn't fit your model. They've already stated this.
Like I said, it's not just gold. There's a lot of different heavier elements, even things like beryllium that aren't purely explained by our model. There's a lot
Interesting
not
fact, though.
that you can't explain it. It doesn't fit your model.
What do you mean by that, Jeremy?
They have their model can't. They have no reason for why there's this much gold. It doesn't fit. It doesn't work in their model because you have to get it from supernovas, like you said, or stars collapsing or some shit. But there just doesn't happen
haven't
enough.
completed the calculations yet. That's all.
Oh,
Hey Phil. Hey Phil. If I go
Hold
to
on,
Jupiter,
let's just take that in for a minute. We just haven't completed the calculations yet. That's all. That's why we can't explain it, because we haven't completed the math yet.
I got a question for Phil. Well, hey Phil, if you were to Jupiter, how much would I weigh on Jupiter, Phil? If the buoyancy, okay, if gravity, you want to use the gravity, but then I would have let's say it's triple. Let's just make it an easy round number. Say it's 10 times the gravity of Earth, but it's 10 times the buoyancy also. How much would I weigh on Jupiter?
Weight
got the
is
math
the
worked
amount
out
of
for
mass
that, bro.
times weight.
My bad.
Weight is mass times gravitational field strength. So whatever
but I weigh less in a pool, in a swimming pool. So if I'm in a fluid and the buoyancy is 3 times more, because that compressed gas would be a fluid liquid type, like propane, and you compress it into a thing. So when you weigh me in water, I weigh a lot less. Okay, so I'm wondering with 3 times the buoyancy, what would my weight be on Jupiter?
What do you think buoyancy is, first of all?
It's the equation for. It's basically the gravity equation for floating. It's freaking
all right.
The density of the matter, buoyancy force equals the density of the fluid times the amount displaced.
Okay, all right. So you understand that it relates to the gravitational field strength, right?
That's my whole point. Yeah, that's my whole point.
Yeah, that's good. So if you increase the gravitational field strength in terms of buoyancy, and gravity is on the denominator, isn't it? So the greater the denominator, what happens to the fraction?
Yeah. Okay, they cancel, but listen. So I'd weigh the same.
Doesn't the fraction get smaller?
Wait, repeat that again. You're talking about the numerator,
the greater the denominator. The smaller the fraction, yeah?
Are you talking about M1 times M2 over R squared?
No.
If the denominator increases and the numerator is held the same, then it's a smaller fraction.
No, gets to be a smaller fraction, yes.
Okay, yeah.
Exactly.
Yeah.
Okay, so that should answer your question.
So it wouldn't cancel out the buoyancy. So if I was in a tub of water, I would weigh more on Jupiter in that tub of water than I would in a tub of water on Earth.
So just to simplify it, when you talk about weight, you're talking about force. You're talking about force. So you're talking about mass and gravitational field strength.
Just talking about the downward force. That's all we're talking about.
Yeah. So this is simply this. If you want to know what you weigh,
we can all figure that out. But that's why I threw myself in a bathtub because you're a professor, man. And you don't get easy questions, man. We got to give you a tricky question, man. Think about it for a second, man.
In your calculations, does the medium you're in not matter?
That's fine. Okay. Yes, of course, friction matters. You've got to take
tells you I'll weigh the same in water, just so you know.
Okay,
where in your calculation? Hold on. Where in your calculation did you account for the medium?
Okay, so in weight, you don't have to. We're not talking about the medium when we talk about weight. Okay. So
that's an
so
integral
weight
part to determining the
is the amount
downward
of
force, isn't it?
Yeah, weight is the amount of force that's applying to you. Of course, if you are in the sea, you have to think about the amount of force that's applying to you and multiply that by the gravitational field strength. Okay. So
Yeah,
sorry,
but
I
density is
misspoke.
basically opposite,
So
right?
the force is the amount of gravitational field strength by your mass.
Right, but buoyancy is basically like the opposite of that, but depending on the density and the amount of fluid that you're in. So if I'm in the same amount of water on Jupiter,
Well, now
and
you're talking about buoyant force.
yeah, that's what I said. I ain't gonna give you an easy question, man. You're the professor, man. I'm giving you a tricky one.
That's okay. We can talk about two different things. There's weight and then there's buoyant force.
But
Okay?
Phil, the two are intimately connected.
Naturally.
Why are you calling them two different things? I'm trying to understand that.
Well, they two different things in that sense. That they two different ways of working out force. So they both force.
It's because this is where they lose. This is where you lose,
what?
Val.
What have we lost?
The argument about this weight, fantasy, gravity, space-time bendy bullshit.
How have we lost it when I can use exactly what I've said to make incredibly precise predictions?
Because I'm away the same on Jupiter. Because I'm away the same on Jupiter as I do on Earth.
Have I
I'm
lost
in water,
anything if I need to?
But if I'm not in water, I'll weigh more on Jupiter. Does that make sense?
How have I lost anything? If I can use this to make predictions. Why is that losing?
Like if
Losing to who, by the way? You?
No, I'm not claiming you're losing. I'm just saying not yet. But listen, so if buoyancy is basically the water displaced, right? So what about the methane that comes from underground? It's displaced from underneath a little vent that there's no water in. Then it gets to the water, and then the buoyant force would work because it'd be displacing water. But why is it coming up out of the ground? That'd be like putting a soccer ball at the bottom of the ocean, putting a plastic tarp over it, and you thinking it would stay pancaked to the bottom because it's not displacing water. Why would methane seep up to the top if it's not displacing water?
Methane is pretty light, you know. It's only
my argument exactly.
Methane is 4 hydrogen atoms and 1 carbon atom. So that makes
that's my argument.
That makes it 16 grams per mole. It's pretty light.
That's my argument. But no, but your argument is buoyancy, so it's the displacement. But if it's just in a pocket, okay, if it's just there's a pocket that's way up under it's way up under the ocean.
It'll stay there. It'll stay there until it's disturbed. I mean, there are reserves, for instance, of propane all over the world that are underground, and they've been there for millions and millions of years. And it's only until we drill and reach them that we bring them up. Or for instance, methane that's trapped in coal seams, for instance, that comes up when they do fracking.
I have a question. How do you know they've been there for millions and millions of years?
Well, there's lots of ways of radiometric dating stuff.
On the pockets of the gas?
There's all sorts of from where the gas comes from. So once you know where the gas comes from, then you can work out how long that would have been there for. And if you do get some materials, for instance, one of the things that we do get with gases is oil and sometimes shale and stuff like that. And those sort of things will give you solids that you can use to do radiometric dating, and that'll tell you pretty much how old they are. I mean, it's the easiest thing to do with radiometric dating when we actually have things that were once alive.
Yeah, my argument is that the methane is it's lighter. You know, it's going to come up. It's lighter than.
Well, you're damn right about that. Right? It will definitely come up because it's lighter. Good point. You're a genius today.
Well, see, no, I'm just telling you that buoyancy doesn't work. So the best argument I've got yet for the buoyancy is that is that the bottom of the methane is heavier than the top of the methane in the pocket, right? Because it's not touching water. But here's the problem. So if I was to wrap that whole methane pocket in a balloon, then the whole methane pocket would rise. So the bottom being denser than the top wouldn't matter. So my point is, if everything works
that
due to
didn't make
equilibrium,
even the
there's no getting
slightest bit
around
of
it.
sense. I'm sorry. That didn't make the slightest bit of sense.
Yeah, well, I mean, nobody's given me a response. Nobody tied gravity into why the methane comes from pockets from underground that are beneath the ocean naturally.
Why don't we spend some time? I'll get my whiteboard out. Not today, but we'll do that, and then you and I can have a lesson. How's that? Would you like that?
Well,
Let me clarify. That sounds, Brian, can I clarify what you're asking exactly? Because, okay, so the methane is in pockets under the ground, under the ocean, right? So water on top of the ground, and in that ground under the ocean, there's pockets of methane. Your question is,
yes,
what makes that methane come out of those pockets from underneath the ocean?
What makes it go up and what makes it rise to the water to begin with if it's not being displaced?
Oh, what makes it rise from within the dirt, rock, under the ocean, and come up into the water?
Yeah, it's just in a pocket, it's in a loose pocket.
It normally won't unless there was some disturbance that gave it some opening.
Because you're saying in order for it to be buoyant, there has to be something to displace it. If it's just sitting there in a pocket, there's no reason for it to rise.
Yeah,
is that what you're saying, Ryan?
No, not at all. It's under a tremendous. It's under a tremendous amount of pressure.
Yeah, so it should compress, right? Like Jupiter does, right?
No, as soon as you give it as soon as you give the molecules an opportunity to have less pressure, in other words, given an opening, then of course it's going to increase. That's the same sort of thing happens if you press the button on a can of spray. You're letting some of it go.
So you're saying it's trapped in
it's
there,
not really
and
not
maybe
different.
the plates shift or whatever, or there's an earthquake, and that's what forces the gas out of those pockets up into the water?
Well done. Well done.
Well, you're skipping over an important point he just made. If the gas had more space, it would fill the volume, you're saying. Did you just say that, or did I hear something?
As long as there's enough energy, then gas will move. It'll have kinetic energy and it'll move. It stops moving when
this. Acting there, man. This gas just compresses into more gravity. Okay.
It stops moving when there's less kinetic energy. Okay. That's why 99.9% of the Earth's atmosphere is below 30 kilometers.
I'm just wondering, man, under all this pressure, shouldn't it be compressed into something denser, like these planets?
No, it won't. Look, if you have sufficiently large molecules, I mean, where you find methane, you're going to find other things. For instance, you're going to find coal. You're going to find also some other large molecules.
The pressure would seek relief, entropy, right? It'd follow entropy.
It's
equilibrium, right?
Okay, so as soon as you release the gas, because you've given it some sort of opening, as Brandon pointed out correctly, then that pressure will be released. You'd expect that, wouldn't you?
Now let me make my final point, Phil. So with gravity on its side and all the fucking whole entire ocean and all the ground underneath the ocean, it can't hold this gas down. And you think there's a line up a few miles, 50 miles up, that holds gas molecules in and just lets some of them escape and holds most of them captive? Is there even saying that implies there's gas leaking out? Why
does
gravity
hold
doing
all
its
the
job?
gas down. Mostly the gas does stay there until you actually go exploring for it. It does stay there. That's quite correct.
So there ain't no natural methane vents all over the world.
The ones that are method usually come from coal seams. They're not that far down, by the way. Like maybe 600 or 700 meters you get a coal seam. So they're not far away, and that's where the methane comes from. So the methane comes from, bacteria that's breaking down materials, carbonaceous materials.
All right, interesting.
Oil,
So,
though, comes from animals, plankton and the like.
Phil, something brought you to join the show tonight. I think it was something that Gleam said that kind of got you worked up.
Oh no, I don't care when Gleam's got this. Gleam's got this thing about Lorentz, which is wrong, and it doesn't matter. I'm not actually interested in discussing that.
Oh, okay.
Time dilation is something that's known. So there's a difference between the clock on the satellite and the clock that's on the ground, and the reason for that is time dilation.
Good job. I said length contraction was ad hoc.
Yeah.
Thank God for that.
So you've got this gravity wave traveling at the speed of, hold on, Brian. You've got this gravity wave traveling at the speed of light.
Is an extremely useful piece of mathematics that we use today.
Lorentz made it. Of course it is.
We use it today, and it's extremely useful.
No, of course. Yeah, of course. Okay. I'm an avid supporter of Lorentz. There we go.
Yeah.
I'm Juan
exactly.
Carter.
So why you were tagging me beyond me?
No, he admits in his own writing if you read his writing.
Sorry, go ahead, man.
His whole theory is called Lorentz electron theory or Lorentz ether theory.
There's no ether.
Can you give us a quick rundown of what that is? The Lorentz ether
theory? Lorentz's theory's wrong. What?
No, the ether bit.
That is a non-scientific thing to say there, Professor Phil, because I see people like Mr. Siegel, who's a science communicator, saying that there is no evidence against ether and there is no evidence that's absolutely conclusive in favor of it.
There's no evidence against God either.
Exactly. But so you just said like God doesn't exist, but we can't prove it. That's what you just said.
In my opinion, I'm just simply saying this now.
Oh, so it's an opinion now. Sorry. Okay. Your opinion versus my opinion.
Yeah, that's usually the case. We scientists, we form opinions based on evidence, and some of us will form different opinions. We're not all the same.
That's why John Bell, the guy who proved quantum mechanics is quantum mechanics, kind of like. He was an avid supporter of Lorentz's ether absolute framed. Yeah. He didn't win a Nobel Prize though because he died before getting nominated. Poor him. But salute to him as well. One of the best scientists in history.
There's no reason not to be a supporter. It is a fantastic piece of work that was done. And have you ever seen somebody? Have you ever watched somebody actually derive this formula? It's actually quite brilliant.
Yeah,
I'm happy to do it. I'm happy to do it sometime on the board. I can do it on the show.
I've seen it.
Do a presentation of it if you like.
I've watched it. Khan Academy's got even videos on it. I've watched it. You could do it on here for the show. That would be brilliant.
Yeah.
The history of it would be nice as well.
I'll put together a bit of a presentation. I think people might be interested in it. Yeah.
Lorentz, basically, for the audience, Lorentz was Einstein's teacher. Or professor, should I say, in the University of Leiden. And that's where Einstein got space-time from, or he nicked the Lorentz contractions.
It's mostly, I think you could say special relativity is really the biggest contribution to Lorentz, for Lorentz. So time dilation, length, mass, just about anything really.
Yeah, I'd say the opposite.
And don't forget though,
Einstein's writings.
Have you heard of the Broglie wavelength?
Yeah.
Yeah. Okay. Well, we can tie all those things together. It'd be interesting.
It would. I mean, what was interesting is what you just said there, because Einstein himself said LET, or Lorentz ether theory, the neo-Lorentzian version, not the absolute frame which is detectable, but the relativistic ether theory, basically. Einstein said in letters to Lorentz how he believes that general relativity was more alike to Lorentz's ether theory, which was same maths, obviously.
Look,
but I know nothing. I just looked it up.
Let's just do a presentation on it, and then it'll become clear.
So you said something that I found interesting, Professor Phil. You said that the clock on the, I think it was spaceship, and the clock on the ground will show different time.
Different, yeah.
Right, and I've heard this before. I think I talked to George about this.
They're very, very small amounts, but still significant enough for us to consider it.
So if I had, does it matter which kind of clock I use or which kind of watch? If I took, say, a
so
Casio watch?
we're talking about stuff that we're talking about stuff that can measure in the 10 to the -6 of a second, so a millionth of a second, and less.
Can I
Atomic clocks.
We're not talking about your average watch, okay?
Hello.
Yeah. Hey, Crow.
Yeah, I like to ask almost the same question. If we have a mechanical clock that has that kind of accuracy, would it be affected the same?
Yeah, if it was if there was the ability to have a mechanical clock, which there isn't, with that kind of accuracy, then the clocks would be different, as they are with atomic clocks, of course.
Okay, thank you.
Are the atomic clocks the only ones that have been used to confirm?
We're talking about measuring at 10 to the -6, to 10 to the -9, to 10 to the -12. You're talking about a very, very small space of time.
It's tuned into the frequency of vibration of quartz, let's say.
Yes,
or something like that.
That's how your watch would work. Not only that, but the thing about it is that when you look at the mechanical aspects of it, so your watch sort of ticks away at 1 second at a time. It is so crude. It is so crude compared to the type of clocks I'm talking about. There's no way you could make a mechanical clock that.
No, I understand
That's
that.
it.
The whole thing.
It's done at the atomic scale.
What I'm driving at is, do you think that time itself actually goes slower or faster, or is it just
yes, it does.
the measurement?
Yeah, exactly.
This measurement.
Actually,
that's affected.
Actually, it does. Actually, I love your question. It's really, really interesting, and I'd like to give it more time because it'll help me explain what space-time is. I think your question is actually very, very good, Brandon. I'm really impressed with it. So when you think about Brandon, when you think about time as being let's say it was a construct of something that's uniform. So in other words, we can break it up into some sort of uniform thing. We do, in fact, do that. We break it up into seconds and we make them uniform. So if we say that time moves along in some sort of uniform way, and that position is also something that's uniform, so that's if it's unaffected by anything else. So where you are in space or where something is in space is a three-dimensional thing. Now, if you think about the three-dimensional aspect of something, and no matter where it is, it's affected by time as well. So there's nothing that isn't affected by time. So these two things are now form a uniform grid, if you like. There's the position and then there's the time, both uniform. But now what happens is we now introduce something to it, which is the mass of something. And by introducing this mass into it, what we do is we actually deform the nature of that beautiful, perfect grid that we had with position and time. We now have deformed it in a way that anything moving through that path now has to follow the path that's now determined by that amount of mass that's there. So, in a nutshell, that kind of describes what happens with some mass in space-time. Okay.
Interesting. That's an interesting way of explaining it.
Okay.
That's fucking word salad. Yeah, it was real interesting.
Well, I don't know if it was word salad. I think I understand what he's trying to say, but
Jeremy. Sorry.
Listen, what's the mechanism at which a mechanical clock would tick differently than a different mechanical clock because we're going fast? Or we move it or whatever your time dilation bullshit
I told you that the mechanical clock would not would not be.
No, wait. They're using light.
So the mechanical clock. Hold on, Brian. So the mechanical clock would tick the same as the other mechanical clock?
So a mechanical clock, when you set them together, are going to be are going to tick in the same way. They just they have a mechanical way of determining time. Okay, so in other words, we use a cam or something like that, whatever it is, to click at the same time, and that's how we measure time. And that's how we break the time up. But we're not talking about that. We're talking about vibrations of atoms and stuff like that. So
measure it with light. But don't you realize they've slowed light down to 4 meters a second by introducing a near zero medium?
Are you claiming that the mechanical clock?
I don't think Phil was done with this.
It's over. I wasn't done either. It's over though. Rumpus is here.
Jimbo, he's just got his microphone open.
Please don't let Rumpus take over the show.
I'm a bit worried by what Professor Phil just said. That's all. He seemed to be implying.
Don't be worried, Rumpus. He's the boss. All right.
Sorry, Professor Phil. Were you just implying that a mechanical clock, say on the ground level of Earth and in space, say at the ISS, would go at the same speed?
No, that of course it would, because like I just said before, in umpteen times, that time dilation is a thing. Rumpus.
Okay, hold on. Before you guys get into a circle jerk here over time dilation.
They're playing good cop, bad cop, Brian.
Yeah, what's the mechanism at which the clock would tick differently for either clock?
Time dilation.
No, something has to physically make that clock tick different.
The reference frame.
Where you are. Exactly.
They're basically saying math. That's why math.
And the speed at which you're moving.
Why would speed make the clock gears go slower or faster in relation to the other one?
It's fucking bullshit.
It's retardation, dude. If you think that shit's real.
It's observed fact. We rely on this. Your GPS relies on this phenomenon.
Yeah, no. You ever thought that the medium? Okay, they've slowed light down now, Rumpus, to 4 meters a second. Okay.
Yeah, not in a vacuum. They haven't.
By introducing a near zero temperature, okay? You think so? They're using light for most of this shit.
This is irrelevant.
Hold on, Brian. I didn't get an answer to my question.
Yeah, go.
I didn't get an answer to my question. Why would the gears of one clock move slower in relation to the other just because of how fast the clock is moving?
Exactly. There's no rhyme or reason.
Because of the distance that light is traveling.
It's exactly that. It's exactly that.
They've done proved that light is not
have to, hold on. What does the distance light has to
guys,
travel?
Give Brandon a second here.
How's the distance light has to travel have anything to do with the clock's movement?
Because the speed of light, the c, that is actually that's the constant as according to
math.
According to the laws. No, according to Maxwell's equations, and then later what Einstein had also used. So if you use that idea that c is the constant, the speed of light is constant, and you have let's say a train car moving left to right, and you have the light bouncing from the floor to the ceiling in that train car, that would be going a certain speed to the person in the train car, a straight up and down path. But a person observing this train car would see that same path would be making diagonals, up and down diagonals, and those paths would be longer.
Yes.
But those actual distances are going to be longer. The speed of light's going to be the same the whole time. So something's got to give, and the thing that gives is actually the relative time for each observer.
That shit was more worked out than Phil
Is it
gave us.
just what the observer
clock-
sees that is
All right,
impacted?
let me just.
Is it just what the observer sees that is impacted?
So the
Or
clock
is it the
will-
actual
Observer.
physical clock
It's to
moving
the observer.
slower?
Okay.
I don't know if people heard my question. Is it the actual physical clock is moving slower than the other physical clock, or is it just the observer observing a difference between because of the
Yeah,
difference
you
in
got
speed
it,
of light?
Brandon. You got it, Brandon. It's the difference in time. There'll be a difference in time, but the clock's the clock on the ISS is the same as the clock on the ground. The two clocks are the same, but however, they will record that if you compare them, the time they'll be different.
Why, you just said they're ticking at the same speed.
Here's a good way. Here's a good way to explain it. Put your clock in the middle of the Earth's core, and then if you imagine looking out at two clocks, there's something in the general chat which shows it. There's two clocks away. Now,
Yeah, 'cause
based
the
on
math,
the
that's what they're saying.
yeah,
But
based on the
they've
based on the
already
speed of light.
proven-
Wait there. This is the pinnacle point. Based on the speed of light, you will see one clock moving later than the other, even though they're both moving at exactly the same speed.
So it's
a
just
relativistic
how they look
thing.
from the viewpoint of the observer, Gleam. It's not that the actual clock is going
That is
slower.
the very basic version of it. Yes, it's an apparent thing, but due to reference frames, the exchange of reference frames from one
So-
observer to the next.
All right.
But it's a real
It's a
problem.
very real
okay?
thing.
So how does if the
It's-
clocks are
it's
ticking
real
at the
thing.
same
real
speed?
problem is it's
Hold on.
temperature
Brandon,
dependent.
Brandon,
They've
it's
proven
not.
it.
Can I just answer Brandon's
Oh,
point?
hold on a second, Rumpus. Hold on. So if the clocks are ticking at the same speed, why does one person supposed to age faster than the other?
Rumpus is about to answer.
Yeah, the
Moving
damn it,
at
I ruined
different
my flow there.
velocities.
Sorry.
Brandon, you might be thinking it's just an observer issue, and for instance, if you set this clock up and it was going really quickly, let's say near the speed of light up in space, and then it stopped, you would see the clock moving more slow. The ticking would happen more slowly, and I think you're getting the sensation that if you then stopped it, it would then sort of jump back to your time. It won't. It has gone through a permanent change, and so when you then go and see that clock. When you bring that
So
clock
it's
back,
physically
oh,
ticking
can I
fat
just
different.
finish the goddamn thing.
You just got
Jesus
done. You guys
Christ, I haven't
just got done
finished.
telling us.
Let me finish.
Hold on, let him
So
finish.
if you brought that clock
Are we
that
talking
you
about
just
time
saw
travel
slowed
here,
down,
Brandon?
and then you brought it back into your frame of reference, i.e. you stopped it going the speed of light, and you looked at it, had it back in your hand, it would have permanently slowed down with respect to the clock that didn't go through that experience. So it's not as though you're looking through some sort of strange mirror sort of thing that some temporary, and if you remove the mirror, it will
All
go
right,
back
we
to
got
where
it.
it was.
That's
So
correct.
time travel. You
Even
guys
though-
think time
even
travel
though-
is possible?
No, even though they
what
just
I'm saying.
got
Are
done
they
telling you.
talking
Hold
about
on, guys.
time-
Hold on 1 second,
Right.
please. They just got done telling you that both the clocks are ticking at the same speed, and now they're saying
No,
they're
you
not ticking at the
That's
misunderstood.
not what he
speed.
said, man.
Here we go. The time in each
That's not what he
reference
said.
frame.
That's what you guys said 2 minutes ago.
No, so you didn't understand. The time that you would be looking, so if you were actually in with that clock that was going along near the speed of light, you would not perceive any slowdown in your experience or time at all. It would only look different from the position of an observer.
Exactly that, Rumpus. I agree 100.
Bingo.
Okay, so now
What
they've
Phil-
slowed light down to 4 meters a second now. It was
That's
9.
a
it
whole
was
new
15.
subject, Brian. That's a
That's
completely
By
totally
different
introducing a
subject.
medium,
Uh,
listen, they have proven that
Brian,
light
this
is
is a
temperature
completely
dependent.
different subject you're bringing
Brandon,
up.
are they talking
No,
about
because you're
time
basing
travel?
this whole thing on light speed. So you're saying the whole rest of the
No,
world
that's Brandon.
went
That's
faster
Brian, that's a
than the
different
fucking
No, you
light
can
that
slow
they
down
introduced.
light in a dense medium, Brian. That's a completely separate
Can
issue
somebody
to what
answer me?
happens when you move an object and what happens to time.
What do you
Yeah,
say,
well,
Silent
Phil,
Zero?
Are these people?
Yeah, well, listen, let me get to my
yeah,
point.
Are these people talking about time travel?
Yes, I believe that
Yeah, pretty
this
much.
is what you would call time travel.
You can
I mean,
you
you're
can only
always
slow down.
traveling
No, you
through
can't go
time.
backwards.
And
You
you
can
guys
just
are
simply
arguing with
slow.
these dummies?
You can simply slow the rate of time travel that time processes with respect to another observer. That's all you can.
According to you, we could send clocks into the future. Okay.
Yeah.
So, for instance,
Yes,
Now
but
listen.
that
to
is,
this.
this is
Let me get to
for
my
instance,
point right
Brandon, I
quick.
could
My
say-
That would
point
be,
is,
that is
guys,
the end
Hold on.
logical result of what you're saying,
Okay, so
Rumpus.
here we go.
It's the
Here is
Havel
what-
Keating
Brian,
experiment. that
Brendan,
you
if
said
I
about.
were to send you off at the speed of light to a star that was 50 light years away, and then you came back again, you would not have aged at all, but to everybody else on this planet would have aged by 100 years, 50 years there, 50 years back.
Exactly.
By
Time
your
travel.
clock,
They
you were in a
are talking
room.
about
Why-
time travel.
You were in a room with a clock ticking the whole time. Why would you not have aged?
because you were going the speed of light, and then.
But you
going
were
the
in
speed of
the
light,
clock was in the room.
I know, but in his hypothetical,
By 1
yeah.
second. The clock is
You are
only ticked
traveling
by
with
1
it.
second.
You're in a
Brandon-
room with a clock ticking, but you're not going to age. But the clock's going to
So,
tick
hold
for.
on, guys.
Just
So
try listen,
what?
Jeremy. Brandon in the spaceship who's been sent off to 50 light years away and come back again.
He's got.
As far as
All right,
I'm
he's got a
concerned,
clock with him.
oh
Hold on.
my God! It only
Hold
took
on,
him, let's say, a fraction of a second to do that. So he didn't age at all. The clock didn't tick at all. He didn't experience. He thought it was a really fast trip, and he will experience it as a length contraction. He will not experience it as a time, but he will see. Oh, look, that star that was 50 light years away. Oh, suddenly it's very close to me. That's the experience he will have. Of
So the
something
clock's
very quickly.
Hold on a second, Rumpus. He's in a spaceship. There's a clock next to him. The clock's ticking the whole time, right? 50 years worth of light speed travel.
Only no, in a fraction of a second. Let's imagine that the clock shows a second between him going 50 light years away and then back again. Brandon.
Why? It's going to take him 50 years to get there.
The Brandon will have
Why
only
would the
aged
clock
by a
only
second.
take 1
Let me
second when he
finish.
traveled for 50
Brandon
years?
will
You're
have
making,
only aged by a
you're
second.
making up
The clock
nonsense.
will have only ticked by a second, and you keep on interrupting me. Stop it.
You're making up nonsense.
No, I'm not. This is a fact. This is what GPS relies on, you moron.
Listen,
No,
he's
no,
in
I'm
a-
gonna tell you
he's
what
in
it
a
really
rocket.
relies on.
Guys,
Like
let's
that.
just calm down a minute
based
because this
on
is
this.
interesting and we're going to get Rumpus all excited.
Christ.
Let's just hear this out.
Jeremy's
It sounds to me like they're talking
He
about.
seems to have turned into some sort of systematic interrupter now.
It sounds,
Brandon
it sounds
just traveled-
like double speak to me. I've got to be honest with you because you're saying
I know
the guy is sitting
It
in
is, Brandon.
here's where I'm stumbling, and I think this is where Jeremy is getting caught up too. You're on the spaceship. All right. My twin brother's on the ground. I'm on the spaceship. I go off the speed of light, whatever. And I'm looking at a clock in front of me. The clock is going its normal rate. My twin
No,
brother's
it's
on
not.
the ground. He's looking at the clock.
No.
The clock
got a
is
problem
going
there,
its
Brandon.
normal rate. Then I come back
you-
and somehow my twin brother's aged 50 years.
But it's not going from the observer, from your twin brother's point of view. The clock has almost stopped, and you experience the reality very slowly
Rumpus,
at the same speed as the
Rumpus,
clock.
how does the
Let
fucking
me
clock?
finish my goddamn answer. I'm
How
going to
does
give you
the
5
fucking
seconds.
clock?
I'm going to give
Hold
you
on.
5 seconds.
Hold on, Silent Zero. I'll
So
let you
will
ask him
experience
after
the
this.
clock. You will not experience the clock having changed its behavior at all, but you will be experiencing life slowed down. The atoms in your brain and things will slow down. Your whole experience of reality will have slowed down. But what you will see is a contraction, a length contraction of the world, the reality. Let's suppose it's the center of the
Word salad bullshit.
No, you just don't. Center of the galaxy. I can't remember how many light years away. Okay, so somewhere that's 50 light years away, you would see that distance contract to be very close to you, and then you would sort of get there very quickly as far as you're concerned in terms of distance, and then go back again, and the clock will have only say advanced by a second. Say, let's suppose you've got it
He's
slightly
talking
below
about
the speed
Star
of light.
Wars, guys.
Brandon's
Star Wars
clock.
shit.
The
Star
speed
Wars
Brandon's-
shit. He's talking
you only
about
have
Star
to
Wars
do a second
shit.
to do that
Please.
journey. But your twin brother will see that the clock has slowed down, and you will not experience. You will only experience a second of time between your start and returning back to Earth. Jesus Christ!
Can I interject,
Okay,
please? Can I
time
interject?
travel. Silent Zero, go ahead. You had a question or a comment.
No, he's talking about Star Wars shit, how they go hyperspeed or whatever.
Yeah, let me just
Essentially,
straighten this
yeah.
out real quick. Hold on, guys.
Okay, and after that,
Who cares?
after
Who
that,
cares
I
about
connect
that
this
shit,
to
man?
reality. After that, Jeremy,
Hold
I
on.
want to connect this to reality, tell them what's really happening.
Go ahead,
All right.
Jeremy.
Yes,
So
based
you're in
on
a-
Brian, it is reality.
So Brandon's in the spaceship. He's looking at his clock. He travels 50 light years away and 50 light years back. So his clock just ticked for 100 years, right? Brandon's
No.
fine.
No.
By 1 second.
Jeremy doesn't.
His clock only
He
ticks
traveled
like
100
1 second.
meters. That's what he sees.
So Brandon just traveled 50. Hold on, Chike.
100
So Brandon
meters
just
he
traveled.
Jeremy, he traveled
Shut the
100
fuck
meters.
up! I'm in the middle
shut
of
the
something.
fuck up. Go ahead, Jeremy.
I'm explaining it to Jeremy. He didn't travel 50 light years. He traveled very short distance.
No, he did travel 50 light years.
No, he didn't see it. As
Shut the fuck up.
Okay. Let Jeremy say what he's got to say, and then one of you guys can respond to him. Go ahead.
Hit us with some more word salad after. Yeah.
I think. Hold on, Jeremy. I think I know what's wrong. Rumpus, you said he traveled 50 light years.
Correct.
But he traveled a distance of whatever that take light 1 second. I don't know how. I mean,
I'm saying
it's
there and back.
I'm saying that, let's imagine that he's going a speed that's very close to the speed of light, so that it's not quite zero. Let's make it a second.
50 years passed.
No, if he's going at the speed of
He
light,
changed it. He changed the analogy.
No, I didn't. He's going.
No,
very
same
close.
analogy. Same analogy.
A
He
light
traveled
year
50
is how
light years
fast
at
light
near the
travels
speed
in a
of
year.
light.
Right.
So therefore,
Right. Light years is a distance. Remember, light years is a distance. Okay, so let's not get that confused with time. So
nobody's
I'm saying,
confusing it. Nobody's confusing it. I'm on the same page as everyone. You know what? Go ahead, guys.
I'm saying that
Just go ahead.
went on
Okay,
a journey.
let me say what's really happening. No, we understand what you're saying, Rumpus. I understand what you're saying.
In 1 second, he went from 50 light years away and then 50 light years back in 1 second. So he did 100 light years in 1 second. He would
Now,
only
let me say what's really happening.
The clock would only advance by 1
in
second.
1 second.
He would only. He would not experience. And he would only
Let me
experience.
please say what's really happening in
Let him
reality.
finish,
A
Brian.
length contraction, but his brother would have aged because he was talking about going the speed of light. That would have been 100 years for his brother. Jesus Christ!
Okay, thank
Right,
you.
it's just
Rumpus.
repeating
Go ahead,
itself.
Brian.
It's repeating itself.
That's
Okay, here
science
it is,
fiction.
y'all. Here it is. So what's really happening? They're finding out that light speed is temperature fucking dependent. So that little billionth of a second that they have to adjust GPS clocks to is because it's colder up there where the balloons
Why
are.
are you interrupting now?
Where they're
Why are you
bouncing them off
interrupting
there.
now, Trumpus?
I've got to
just
go.
making
We're getting
stuff
really
up now.
stupid now.
No, actually,
they bounce a
wait,
signal to
hold
the
on,
moon, they
Phil.
think-
I think that was a good point that Brian just made. It is light is affected by temperature. The speed of light
Not
is.
in a vacuum, it isn't. And it's only affected by density.
Where's
It's not
the
affected by
Where's this vacuum at, Rumpus?
in the space that you travelled in to go 50 light years and back again.
No, Brian was referring
Now
to.
remember, our atmosphere goes out past the moon.
The actual
No,
thing
it
that you
doesn't.
said is a practical application of this concept.
GPS uses these things we've been talking. Phil and I have been talking about. Absolutely relies on this phenomenon to get you the distances correct. And it has to allow for two relativistic effects. One, the fact that satellites are moving 17,000 odd miles an hour, which has an effect on the time. But there's another effect in relation to being the surface of the ground. The fact they're further away from the Earth means that the gravitational field is less, which means they experience going faster. But the special relativistic effect makes things go slower. So there are two effects going on you need to account for to make GPS work.
You know, Rumpus.
Can I give a GPS analogy that will probably help and probably simplify the whole thing? If I've got a GPS phone or a receiver on the ground, and I've got a satellite which is, let's say, 16,000. Let's just say, for argument's sake, 10,000 miles up, and then I've got another GPS satellite which is 20,000 miles up, and let's say that light is a lot slower than what it is. That those two satellites are constantly pinging out every couple of seconds a signal to say, I'm here, I'm here, I'm here. Now my receiver is receiving the lower altitude one before the higher altitude one. So the difference, the difference in the reference frame, because light takes the same amount of time, obviously it's going to take double the amount of time to get here.
No. It's going to go slower where it's colder. Look, listen. You're not going to get a zero temperature without evacuation. All this shit they've done in the lab, they've had to leach the fucking air out to get a temperature that low, to get the light to go that low. So don't tell me it's because of fucking pressure. Okay? It's in a fucking damn near perfect vacuum. To get the temperature down that low, you have to have
You are
Really?
just
Am I?
making
So
stuff
what is the
up.
leaching process, Rumpus? What describe us the leaching process to get a vacuum or to get cold temperature?
What leaching process?
The chemical leaching process, okay? You see, you don't know nothing about it, bro, so don't tell me I'm making shit up.
You are
Okay,
making
now let me
stuff
say
up.
this.
You are
Okay,
Aren't some of these in the
If you
thermosphere
think
though?
light changes
Boiling
its
up.
velocity as a function of temperature, then I mean I could get abusive here, but you're just
yeah,
being
dude, they're
very,
getting it
very
slower and slower the closer they get to zero.
No, it
Okay, and
doesn't
this
have
ain't no
any effect.
this ain't no
Right,
Higgs
provide us
Einstein
with
condensate
citation.
either.
Right, provide us with any citation anywhere that scientific.
Go on my channel, dude. I've shown it. I've shown the mainstream
Wait, guys, I
laboratory.
think it's getting lost in the you guys arguing back and forth. What isn't being disputed? That the speed of light is variable?
It doesn't change in a vacuum.
Yeah.
But we
No,
don't
that's
live in
the
a
whole
vacuum,
basis
Rumpus. None of this is
this
taking
length
place in a
contraction
vacuum.
and time
GPS isn't in
dilation.
a vacuum. The receivers aren't in a
Your trip-
vacuum. None of it is.
Well, your trip to this 50 light years away and backwards and forwards is in a vacuum.
Yeah, that hypothetical one. But then we switched to talking about GPS, which are not in vacuums.
Which is in a vacuum as well.
No, it's not. You tell us all the
it
time that they're not in a vacuum. The atmosphere goes out to the moon.
No, it doesn't.
And not
It
only that,
doesn't now.
Brandon. Wait, not only that, Brandon. Listen, if you're going to say I'm on a globe, but I'm really on a flat Earth, you're going to have a fucking
The thing about going to the moon is
transform.
just the odd oxygen molecule or whatever from the Earth has made its way to the moon. That does not mean to
Let
say
me make
you
a comment to
regard the
Gleam.
Earth's atmosphere as being at the
Hey,
moon.
Gleam. If these
Here, let me
GPS
just
ground
hold
towers
on,
are going to
Brian.
say I'm on a ball,
Hold on,
All
man.
right.
Hold on. Effects of heat on light radiation. Let me see. Actually, it was a good quote. Hold on 1 second. I'll just read this to you. The speed of light in air depends on temperature and pressure of the air.
In air.
Okay.
That's 'cause it changes the
So it just
density.
air. That the same thing doesn't
Hey,
apply
where does
to
it-
water. The same thing doesn't apply to gases that the light goes through. Solids.
Let's try it again.
Hold on,
Whereas
Brandon. Hold
any
on. Where does the
medium
air
affects the
The
it's a,
velocity of light is dependent
Rumpus.
on the
Rumpus,
refractive
where-
index of the mix. Just let me finish. Just 5 seconds. Velocity of light is determined exactly by the refractive index. Or the measure. That's what the measure is, and that is determined by the density of the medium it's going through. So it does go through slightly slower in air than it does in.
okay. What is the effect of temperature? Just give me a minute, please. What is the effect of temperature on the speed of light, Quora? This causes the speed of light to vary with temperature. Does the speed of light vary with temperature or not, Rumpus?
Only
where
in
does the air
a
stop?
medium.
So only in air or only in a medium?
Where the air stop?
Any medium. It's
Any medium. Okay, which we're always in a medium, correct? Everything in existence that we are aware of and that we experience in this world is in a medium, correct, Rumpus?
Any
Why
medium.
are you
Funny
talking over
muted you
me?
the whole time.
Why are you doing that?
Determines the speed of light. If the
Rumpus, give me a
temperature
fucking
affects the
straight
density-
answer.
I'm
Is
trying
everything
to
in the
keep
world in a
overtalking
medium?
me.
Yes or
Let
no?
me give you the point. Let me state it, and then you'll get it clearly. The velocity of light is determined by the density of the medium. When you heat air up, it becomes less dense, and therefore light will go slightly faster. If you cool it down, it'll become more dense, and therefore it'll go slightly slower. But the relativistic effects we've been talking about in this discussion so far are not affected by the speed of light in the air, in the atmosphere. We're talking about in absolute terms.
Okay, the variation of the index with temperature is called the thermo-optic coefficient.
Right.
The number
that's
is
all
important
my
in
video.
designing fiber optic and planar light wave circuit devices. This is because of the temperature variation on the speed of light. So it sounds like it's temperature dependent. That's what I keep reading over and over again. If you want to say it's pressure dependent because temperature changes pressure, whatever. But I want you to answer my question with a straight answer. Shut up, Rumpus. I want you to answer my question with a straight answer. Is everything we experience on this Earth, surrounding this Earth, and all the satellites that we have, are they within a medium? Yes or no?
Not outside the Earth's atmosphere. They're not. No.
So the air stops. Where does the air stop, Rumpus?
Hey, guys, can I try to help?
Tell us where the fucking air
Rumpus,
stops.
Rumpus is correct, but he's
And
not.
don't
He's not
mistake
saying
density
it.
with pressure
Hold on,
either.
hold on,
Don't
hold on,
mistake
hold on.
density.
Guys, hold on. Rumpus is saying it correctly, but he's just not saying it with the way you guys are looking for. And what exactly he's saying is that the cause of refraction and the light speed through the medium, it's going to change. The refraction is going to change on the density of the medium, and the density of the medium can be affected by the temperature. This is true.
You're confusing density with pressure.
Hold on. This is an important part. So it really does matter what medium you're talking about and how much that medium changes with temperature. If you're talking about the near vacuum of space, where it's already sparse medium, the temperatures there are not really relevant. They're not really going to change.
There's no vacuum of space,
index.
bro. You're confusing density with pressure. Okay, I've already showed y'all, and this is in one of my videos. What Brandon just read is in my actual fucking video, where and a couple other citations where temperature. Okay, you're not going to get down to a temperature that low without a vacuum. Just getting that cold creates what you would call a vacuum. Okay, just like I showed the balloons being put in liquid nitrogen. The air evacuates. It's still there. So don't say there's no medium. The air is still there, but the balloon is deflated. As soon as it warms back up, okay? And if there is any medium there, you know, like if there's a certain medium, then it turns superfluid around them. And that's how they first slowed light down, was through the superfluid. And I think it was helium-3, okay? But they've found other ways to do it. They've got light slower and slower. And even if the Earth, and this is the gleam, if Earth was flat and they wanted GPS to match the ball, they would of course have to add a transform even with ground towers to match the ball. If it was flat, they'd have to have a freaking
You are correct.
or a reason.
Yeah, no, that's right. That is right.
So, you know,
No, where I'm coming
they
from,
gave us that bullshit.
and where I'm coming from, and I think this will probably back up Rumpus and the Glober side, but if you look up the Silvertooth effect, the Silvertooth effect was by Ernst Silvertooth. He had proposed to have debunked Einstein, and it was found that the difference in light that he measured was due to temperature, and it's due to it being an error deviation in the interferometry. I can't even bloody say it.
Interferometer.
Yeah, I got the interferometer right, but yeah. I'm on three sticks. But anyway,
the key thing to understand is that when we talk about going at the speed of light, we're talking about for relativistic effects we've been talking about. That is the speed of light in a vacuum. So what goes on inside the fact that the actual light itself does change speed in denser mediums is absolutely irrelevant to all the discussions we're having.
I agree. It's underneath that. The medium is a null effect when we're talking these distances on a globe model.
All right,
Definitely
fine. Let's get back to the other subject then. That's fine, because we did change the subject slightly. So we're talking about in a vacuum, but we're still talking about time travel. That's still what we're talking about.
Yeah, exactly. So it's got nothing to do. So, for instance, Brian pointed out that you can slow down light to the speed of no, I can't remember what it is. You can slow it down to a few meters per second. That has absolutely no effect on the discussion about what causes your clock to tick. Just because you slowed it down in a medium to be slow down light speed, that does not affect any of the calculations about how time speed or other relativistic effects. The relative effects we're talking about is related to the speed of light in a vacuum. So whatever the other stuff what light does actually in other mediums is absolutely irrelevant to the discussions we've been having over the last 10 minutes or so.
Well, before... I agree with that. I'm about to leave, but I had been thinking about a very simple explanation. It's kind of on board with what I had already said with the time dilation. It's actually fairly simple. But if you imagine there's two observers and they have these two clocks, just like Phil had said, two exactly identical performing atomic clocks, and one person is on this kind of visual train car that's going through the sky, and another person's on Earth viewing a light beam that is going to the top and bottom of that car, and the train car was moving at such a pace that the bottom and the top of the train car, let's just say it takes 1 second for the light to hit the top bottom of the top, so it's a fairly big train car, and it's moving fast enough to where in 1 second, it hits the top and the bottom of the train car if you're viewing it stationary from inside the train car, but it's moving in such a way that that same distance, the top and the bottom of the train car is now extended to where it's diagonal to where that that line is now twice as long. So it takes 2 seconds for it to appear to go to the top and the bottom. And so what's going to happen is because light is a constant from both observers' point of view, the person on the ground is going to view the light taking 2 seconds from his atomic clock. It's going to take 2 seconds for the light to go from the bottom of the train car to the top of the train car. That's what he's going to see. And the person on the train car is, of course, going to see the light go from the top to the bottom in 1 second. So both their clocks are working exactly the same way, but their clocks, they're going to be appearing to be going twice as fast through time.
So they're just seeing two different things because of the speed of light and the speed they are going relative to the thing they're looking at.
I want to speed of light is constant, but time isn't constant.
I'll say, why do we have to imagine, Kosho? If it's science, why not demonstrate it?
This is because they gave you real demonstrations, GPS and all that.
The speed of light is medium dependent. There's no such thing as a fucking vacuum.
You're exactly right, Brian. But they accounted for all of this in the Hafeld-Keating experiment when they sent it was an Air Force, 2 Air Force jets, one in each direction with a atomic clock on it, and that was the confirming proof of relativity that.
Yeah, but that's only one experiment, bro.
Definitely, we can.
Why didn't they fly the same direction?
United States. We can definitely trust it. Yo, you got some echo, Brian. We can definitely trust the United States government, if anything. So,
all experiments of that type have confirmed the result. There's not been a single case of it being invalidated.
And the funny thing about all this is, if you agree with Maxwell's equations, which a lot of flat earthers do. I mean, because there's no reason to disagree with it. It requires that the speed of light is a constant, and all you have to do is take the idea that the speed of light is a constant, and the scenario that I just played out to you is it's imperative. Like there's no other way that would occur. If the speed of light itself is the constant, then that observation would occur that way. The two clocks would be in disagreement.
We'll say all accreditation to Lorentz for that. He figured that out.
No, well, he got confused.
They got light in a vacuum.
It was him who figured out the electric component.
Kosher, I think if you want to demonstrate what you've just been describing, which is the classic way to explain why the speed of light is constant and the effect of special relativity, I think you need a couple of diagrams. I don't think people will have absorbed what you said.
No, I agree.
From your verbal description.
It's all theoretical bullshit.
No, it's all used in GPS, Brian. It's been verified in every single experiment ever made on this subject.
Show me one. Show me one that you did, Rumpus. Show me one of these experiments you did, or we can repeat.
You want? I have to have done it, do I? I can't relate. I can't link.
I'm not gonna believe it all just by saying 2 jets. Fucking the atoms broke down at different fucking rates, going different directions. There's a million variables that could have caused that.
And
it's not absolute, though, Rumpus.
And we can't even repeat that.
Of course we can. All these experiments repeat. That's
Let's
what makes
do it.
experiments verified by science.
Repeat it.
No, you're wrong there, though, Rumpus, because they have failed. Come on, they're not perfect.
And you can do it.
There's been no verified, validated experiment that invalidates the special theory of relativity and the effect we're talking about.
I don't care how fast you're going. You're never going to be on a different time than me or any other brother.
You're a science denier, and you're denying all the scientific.
No, nature balances itself. Just like with pressure and chemical reactions and everything, nature always balances itself. You're not going to show any of that shit. It's bullshit.
You're just making stuff up. You're just using a sort of
nature works in harmony, dude.
Which is in denial. I mean, if we had used your sort of logic, we'd still be running around banging rocks together in caves.
You might as well be, bro. You'll be stuck there 1,000 years from now because any technology that comes out that doesn't pass peer review won't make it nowhere. So we'll be stuck for 1,000 years.
Quite well, thank you very much. With the current scientific peer review process, that's why.
Yeah, burning gasoline engines invented 150 fucking years ago. We're still burning gas, Rumpus.
I mean, Jesus Christ, you would be being dragged around by your hair and being eaten by flipping leopards in caves in bloody the Rift Valley if you had your.
Ernst Mach didn't believe in the subatomic scale. He wasn't. He was a very clever man, and smack.
I mean, Brian, you seem to be denying all of the scientific research that's been done in the last 100 years. We've built.
No,
on the
you call what you call science.
It's not
You
science.
can't build.
Yeah, what you call science, what I call science are two different things. What I'm
I mean,
just
you're the classic
the
flat
latest
earther.
in
You've
science,
seen it under
Rumpus.
your bed. You don't believe it. You've got to see it
Rumpus.
experience it yourself or under
Brian,
your
you
bed.
got an echo.
That's the argument, Rumpus, not the person.
Ridiculous.
Brian, you got that echo thing going on.
And stop attacking the person, Rumpus. You don't need to, obviously.
They say if they haven't seen it personally, it doesn't happen. They don't understand what constitutes authoritative evidence.
Say we don't understand
That
again, and say an ad hom one more time, Rumpus.
He just did two of them
I
back.
agree with
He did
Jeremy.
two in the same
You are sitting there spouting out that we're stupid for not understanding your fucking time travel theory.
No,
You
I didn't say
expect
we
us
did.
just to
He
go,
did an ad
oh
hoc
yeah,
and
it
an
totally
appeal
makes
to
sense. If
authority
one thing's
in one
going
sentence.
fast, it's time traveling.
Bearing in mind when it was peer
Correct.
reviewed,
I would say-
Einstein
I
said
would-
only him and Arthur Eddington knew how it
Look,
actually
guys.
worked.
No, that was general
doesn't-
relativity.
Listen, if
The what I was pointing out, not being stupid for because relativity, the two
I wanna say
relativistic
something.
effects, the general and special, are not trivial things. To do the maths, you need to basically doing a
you've been
physics
talking
degree.
too much, Rumpus.
Hold
Shut
on,
up.
but what you are stupid, what Brian is stupid for, is to not recognise that people, professionals, and institutions that check themselves. Science is its own biggest critic, and in denying that experiments have happened and things and observations have been made and verified, it's just a denial of reality.
Yeah.
It's not denying reality. It's denying their interpretation of the fucking
May I say
whatever
something,
they're
Brandon?
doing.
Well, you don't
Not
understand how
denying
scientists work.
reality.
You understand science. You are denying science.
Why
I
do you have to
agree
call
with,
it? Why are you so obsessed with calling us science deniers? You sound like
Because you are
a religious person. You deny God. You go against God. That's what you sound like to me.
But the point is, we can prove science. We can be.
He doesn't even actually.
That's why we've got.
He doesn't even have actual science. Is the funny thing. He's got pseudoscience, claiming it's science.
Very, very different.
He's got. If he had actual science, I'd be like, yeah, you're right. We're kind of denying your science. But you got pseudoscience. You don't even have actual science for us to deny.
We have evidence. We have experiments. And
We do.
observations.
We don't.
Yeah, we do.
Can I give you an example of Rumpus of how you deny science?
Jeremy.
Yeah,
Can I give you an
let's go.
example how you deny science, Rumpus?
Go ahead then. Please.
Rumpus, we had an argument on Sean G's show many moons ago, probably about a year and a half ago, and it was about dark matter. Yeah, and you told me that we know it's there. We've got lots of evidence for it. For example, the bullet cluster.
Yeah.
Do you remember that?
I don't remember our discussion, but I certainly quote the bullet cluster as an example. Yes.
Okay, as evidence in favour of dark matter.
Correct.
Okay, now please look up.
You're going to tell me about Sabine
Yes.
in which she said
Saying that it is not. It is evidence
that's her
against
opinion.
it.
I think she's in a minority about that. That's her.
Oh.
opinion.
You haven't
So,
appealed to
so it's an
authority, Howard,
opinion-based philosophy, this science
well, but
thing.
no,
Some can deny it, some can't. It just depends whether you got letters by your name.
The great thing about mainstream science is things like
I want to
Einstein.
say something.
That's what it is.
about
That,
the
it's
whole
an ad
shit.
populum belief.
You
It's an
deny
ad
mainstream
populum.
science. Sabine is mainstream. You're not.
Einstein was
It's an
wrong
argument
about
ad populum.
Einstein
You're just a
was
walking
wrong
fallacy,
about-
Rumpus.
Einstein was wrong about quantum mechanics. Just because you've got a super clever scientist, and Sabine is clearly clever, that doesn't make her right all the time, unlike me. And
Yeah,
so,
but it can't describe the velocity, as she
All right,
says.
Rumpus, let's give these other guys a chance to get in here because you have a tendency to take over. Which
only because
fine.
Silent and Jeremy seem to be specialising in over talking you. Oh no, I've got 5 words into a sentence.
Okay,
You've
that
had
means
a lot
shut.
of words. You've had like
According to
5,000.
according to these clowns,
I'm happy
wanna
to take
say
shut
that-
up and let other people talk.
All right. Silent Zero, I
You're
think you
walking-
wanted to say something.
Yeah, I want to say that I agree with Jeremy on the clock thing, because it doesn't make sense if one guy has a clock and the other one has another clock. Both person are looking at their clock. One starts traveling at the speed of light. Like the person who starts traveling to the speed of light, that person or that clock doesn't care what the other person on Earth is doing. Right?
that's what you're saying, bro.
I never
both
got a chance to
persons-
finish
Hold on,
it,
he's
yeah.
not done.
Both persons are watching their clock ticking 1, 2, 3, 60 seconds, 1 minute, 2 minutes, 3 minutes. They both persons. So the person that stays on Earth, the clock that is traveling, that clock doesn't have a mind saying, "Oh shit, I left this person is watching at me. Now I gotta do some tricky shit so that I don't know, time doesn't go past or something." So on both clocks, they're ticking, and they're both people are getting old. So yeah.
Yeah, I get
Yeah,
you.
I never got
I
to
kind
finish
of
it 'cause
feel
it
the
was-
same way, but go ahead, Jeremy.
No, I mean I was gonna walk them through it earlier. Where if the guy in the spaceship, you're in your spaceship, you're looking at your clock. It's gonna take you 50 years to get to the fucking star and 50 years to get back. If you're watching a clock the whole time, you're gonna be aging that whole time.
No, for you
It's
it's only
gonna
a
take
second.
you. Why you can't travel 50 light years in a second?
Yes, you can. If
No, you
you
can't.
go near the speed of light.
Not if you're
No,
going
you
the
can't.
speed of light.
You can travel 50
Shit,
light
dumb
years.
word
Stop.
salad. Fuck. You're a
Chike,
walking fallacy,
from the
Rumpus,
perception of the
double-speaking
person
motherfucker.
in the ship, it is only take a second. From their perception,
Yeah,
it
and,
only
and in the perception of the person in the ship,
Yeah.
it's
Can you
only a
can you
kilometer.
tell me which? Can you tell me which mind is telling the clock on the ship that they need to adjust for the person that is staying on Earth, Rumpus?
Yeah, and is the sun's light 8 minutes old or not?
Sorry, Silent, could you repeat your question, please?
Is the sun 8 minutes old or not?
Silent, let me. The sun is 8 minutes old. Silent was asking a reasonably complicated question. I didn't get it.
By which method is the clock in the ship or in the starship that is gonna travel knows that the other person is staying and it needs
It
to.
doesn't. All it
Then-
worries about is its own velocity.
Is
It
that
has a
all right?
velocity as a
Is
fraction
the
of the speed of
person
light.
is the person on the ship is gonna watch that clock spin for 50 years? Like it's gonna give you a count of 50 years?
No, he will only. We're imagining this journey for him will only be a second. The clock will only advance by a second for him and the spaceship to get 50 light years and back again. He will only-
Bullshit, man.
One
What's
second.
the
Hold on. Yeah,
Hold on,
I got him. Hold on.
Second.
Let
No.
me.
He will only
Hold up,
second.
Silent Zero, go
1
ahead.
second for whom? 1 second for whom?
For the person on the ship, but for the people on the planet Earth, they will see that's taking 100 years.
There has to be a
Wi-Fi?
Hold on,
What if they're
Brian.
connected?
There has to be a
Oh.
there has to
You
be a
say-
physical
yeah, it is-
mechanism by
it is
which
the
that
movie
clock.
things, yeah.
There has to be a physical mechanism that's going to make that clock tick different. What is it?
No, the mechanism is exactly the same.
That's nonsense.
So it's
It
not
is
gonna
answer
total
math.
fucking nonsense. A
GPS
ship
relies on
goes.
it, Brandon.
If a ship goes for a flight for 1 second and then comes back to its origin 1 second later, a 2-second flight. If you're standing there on the ground watching the ship leave and come back, it's going to come back in 2 seconds.
No,
Yeah.
because
It's
we're
not
talking
going
about
to
seconds
fucking
on the
take
ship.
50 years.
It's
Well,
like
it's a second for the person perceiving it on the ship
If,
that's doing the
I
What
don't,
makes
if
the
your
clock
math
tick
tells
on
you
the
that
ground,
that's true, Rumpus,
you-
listen to me. Your math might tell you that's true, and you might need that for your equations to work. That's not real.
It is. GPS uses that very fact.
No,
By
you're
what
misinterpreting
mechanism? I told
something
you what
that's going
GPS
on with
uses.
It relies
GPS.
on it, Brandon.
You're misinterpreting
relies on
something
it.
that time travel
All
is
right.
not real.
when
The
you
li-
say GPS,
relies on it, and
Rumpus, are you
all the
talking about?
experiments over
Hold
the
on,
last 100 years
hold on,
verify
Rumpus.
what I just said.
Rumpus. When you talk about GPS, you're talking about satellites, like GPS using satellites orbiting
course.
the Earth.
Of course.
All right, well that's a fucking problem right there.
Well, if you're a scientist,
What's the mechanism?
Yeah,
Shut the
to
fuck
try
up
and
with your
explain a
science and
satellite
that
being
bullshit.
so
What's
far
the
away when it's
mechanism
not.
by which-
Distance.
So, Jeremy, what you're really asking is, how can I explain to you the special relativity, which is the one that relates?
No, I don't want to hear
It
your
doesn't
bullshit
exist.
word salad. I want to hear why the fucking clock ticks different for the
I was about
guy
to
inside
tell
the
you,
ship.
but you,
It's a
doing what you
mechanical
seem-
clock.
You did exactly what you seem to be doing in this hangout today, is to interrupt me 4 words into me giving you an answer.
Oh,
If-
Rumpus speaking again.
Yeah, I know. I'm sorry I came back in. I'm trying to shut up a bit, but Silent did ask me a question. So, Jeremy, you basically are asking, how can I justify this what is an extraordinary behavior? I mean,
Hey,
it's
Rumpus,
incredible. When Einstein,
I
Oh,
hate to
God.
cut you off, but I'm going to shift gears here for a minute because I know you could talk about this all night. I'm going to read these
Yeah.
super chats and then we'll come back to the discussion, okay? I'm a little late in doing this. Earth is life. $5. Brian, have you looked at the presentation that Jesse has kindly put together for you regarding surveying in Florida? Have you seen that yet, Brian?
No, but I will watch after this show. Having said that, what Jesse and them don't understand is that, yeah, the math might work the same on a globe as a flat Earth, but look, they're not remeasuring every square inch of Florida. Okay, they're doing curvature corrections. Okay, they're applying curvature corrections. Okay, and when the planar surveys are doing it, they're assuming the water is level. Okay, when they're doing geodetic, that's not really for elevations except for certain circumstances. They're taking state planar surveys, putting them all together, and mapping it with the geodetic, okay, and applying curvature corrections, okay. I could argue the globe for that, but it doesn't prove a globe. But I will watch his video.
Okay, thanks, Brian. JQ, $5. Which clock ticks faster, the stationary one or the moving one? I think we may have got the answer to this, that they both tick the same. The person sitting in front of them, the clocks will tick the same, but for some reason, in relation to each other, they're ticking differently.
Also, the guy traveled 50 light years and his clock only ticked for 1 second somehow.
He went for a 2-second flight, and somehow, for some reason, the place he left aged 50 years.
Yeah,
okay.
but he's traveling at the light speed, right? He traveled.
It takes 50 years.
Yeah, he traveled. No. He didn't travel during 50 years. He traveled 50 light years, which is distance. It's not time.
Well,
Yeah,
the speed he gave the speed was
that's what they're
light.
conflating, though. They're conflating
No, the speed
time
was-
and distance.
Yeah. They're conflating
No,
time
I've
and
got a
distance,
simpler
Jeremy.
one. I've got a simpler one, which is
Hold
just
on.
basically one observer on Earth takes a photograph of the sun and another star. Another observer on the sun takes a photo of Earth and the same star. Now, they should get a mirror image. However, we know that the sun is actually 8 minutes in advance to where it should be. Yeah, when
How do
you
we
took
know
that.
that?
Well, that's based on the maths of the heliocentrical model, but that's
Right.
that's. No, I'm
Hold
not
on,
saying that we
nobody
know
would-
it,
No,
but
let
this is
William
what
finish,
it is
'cause
based on.
He's making a good point.
Yep. So from one photograph, from one reference frame on Earth, the sun is going to be in a fixed location on my photograph. However, in reality, if you was God looking in on the whole system, you would see that in actual fact, it's eight minutes
You were
ahead,
God, dude.
but it's taken the light 8 minutes to get to the camera.
No,
Yeah.
that I get,
Okay.
William. That I understand. That's just
That's
a
a
matter of how
simplified
long
version
it
of
takes
it.
the
That's
light
nothing
to
to do with
get to you.
relativity.
That's not fucking time travel.
Exactly.
Can I
Clean.
just
Absolutely
say
not.
If that
No,
were the
hold on,
only
Rob.
It's
thing
not
that these
time
guys are
travel. It's
claiming,
got
all
nothing
you
to do with time
all
travel.
you
it does
described
nothing
there
to
was
do with
about the
time
speed of
travel. Oh,
light
shut up,
is a
Rumpus.
finite amount. It takes 8 minutes to get.
Shut the fuck
observer.
up.
That is
So
the basis
if that were
of
the
it.
only thing
No,
they were
it's not.
claiming, I wouldn't argue with them. I wouldn't question it at all, because that makes perfect sense. If light goes that fast
And it
and
has
it's that
nothing to do
long,
with the subject.
then
It's
yes.
the first postulate
We'll
of
see
relativity, for
something
fuck's sake,
different, right?
mate.
But the problem is when they start saying that something right in front of you, like this ship is on the ground, it goes off, it comes back. For the ship, it was a 2-second trip. For you on the ground, it's 50 years have elapsed by the time they get back. That has nothing to do with how long it takes light to reach you and looking at things from two different vantage points. You're telling me that
Can I just address this?
it's going to take 50 years for that ship to get back to the same spot and for me to be able to walk over and touch it. But for the people in the ship, only 2 seconds for them is going to have elapsed. That's fucking time travel.
And all
Hold on,
this,
Brian.
Brian, hold on to keep the Earth moving around the sun.
Wait, how is it
Let me address the rocket scenario real quick. Nobody's
Jeremy,
conflating. I've been waiting, bro. What the fuck? Go ahead, Chike. You know what? Go ahead, guys.
How is it time travel? We always move forward in time, so nothing has changed, but the rate of the time changed. For each observer.
And all this to keep the sun
No
moving around, the
one-
Earth moving around the sun. I mean,
No one went back in time.
If time moves differently for two different people, that is essentially time travel. You just
it's not
traveled
time
50 years
travel.
in the future in 2 seconds. That's time travel.
It's time posing.
all
Well,
this to explain Michael's
we
null
traveled
result.
50
Can you go
traveled in 2
backwards?
seconds.
Could I go to 50 years ago? I guess I should be able to if I can
Yeah,
go
but you
forward.
didn't experience those 50 years.
Huh?
No.
You
No
experienced
one
those 50
claimed that.
For you, only
No?
2 seconds move.
Yeah, mathematically, they can calculate it, but it doesn't happen in reality. At least that's what I heard.
Yeah, it does.
Okay. Let me move on with
What,
these
what
super chats.
I want to know is why people can't explain to me the picture of the Isle of Man discussing general or even what is the other one?
Well, I'll tell you why, Chaiki, because we can talk about whatever the fuck we want. And when you come here and tell
Yeah,
us
but
that
you
time
won't-
travel is a real thing, and we tell you to shove it up your ass, it's not. That's just the way it
Because
is.
you have no tools, no means to
Deal with it.
understand it.
I don't give a
You have
fuck
no
what you
means to
think we have
understand
means. You don't have means to tell me
it.
God's not real.
You prove it. You need to know to understand reference frame, what exactly is being talked about, to understand what is being said.
No. I
Trump has
understand
just
what
said it
you're
wasn't
saying.
about reference frames.
I can talk poetry without
Two different
know
stories.
anything about poetry, right?
No. You're appealing to some kind of special knowledge that I don't have the
No,
capability to understand your argument.
No, not special, nothing. You can learn it, but you need to learn it.
I've
You
heard
need to
this
know.
my entire life, this story about time dilation. I've heard this explained by so many different people over the last few years. I'm not buying it.
Okay, I'll give you another
Anybody
example.
who believes this shit,
Different example
knowing
to test it.
paradigm shift, anybody who still believes this shit is borderline retarded, bro.
Never mind.
It's really
Never mind
simple,
believe
guys.
now.
It's really simple, Chike. Chike, it's really simple. If you
Yeah.
guys have are able to show this, why people still argued about this?
No. We will do a little.
No.
How they call it? The mind experiment. Let's do it. So a spaceship whizzing by the Earth at the speed of
Not a mind experiment. No. That's not what I
of the speed
want.
of light. Shut the
I
fuck
want a
up for a second.
demonstration. I want a demonstration.
I
Real life
don't have such a
demonstration.
ship. I don't have such
Yeah,
a
you
ship.
don't have it. That's why it's fantasy.
Well, but
We don't care about your fantasy.
You don't need to have it in order to
We
think
don't care
about
about your.
it. You don't need to have it in order to think about it. Now, when
There you
the
go.
ship
See,
is near
it's all
Earth,
fantasy, Brandon. That's what they got.
okay, let me move on with my fantasy. When the ship is near Earth,
Yes. You can move on with your fantasy tale.
can I talk, please? I'm trying to explain something to you, to show you how simple it is. So when the ship is near Earth, some event happened. Both observer on the ship and Earth see it. The ship is moving 99.99% of the speed of light toward the moon. A second after that light hit the moon, observer on Earth and the moon see it 1 second later. The ship is almost 3,000 kilometers away from the moon, also see the same event. So for the ship, how much time passed? When
That
light
doesn't
traveled
prove that
3,000 kilometers.
time passed differently from the
Same
ship.
thing,
How much-
Jakey.
Even if the light
That
does
is not
take
the
time,
same
don't
thing that
prove
we're
that,
talking
Mikey.
about. We're talking about
distances
physical
for the ship-
objects
It's a physical
going on a
ship is
2-second
physical
trip
object.
and it feeling like 50 years for the people on the ground. That was
I'm
the
trying to
example that
explain-
was given. That's not about how long it takes light to travel.
Yes, it is.
No, it's
Because
not. We're talking
all
about physical
observers-
No,
objects.
it's not.
all observers will measure the speed of light to be the same.
No. If that ship went to the
If
moon,
you say no,
if
I
that
want
ship
to
went,
see
yeah.
at least
Here's
citation for it.
since
At
we
least
cannot.
citation
Hey,
for it.
fuck you! You're not showing anything. Now you're gonna ask me for
He
citation.
wants a citation
Fuck
from you.
off!
Yes.
Fuck off with your
Can
shit,
can
bro.
I show a
Say no.
citation to Rumpus?
Fucking dummy.
No.
Have
Yeah.
a check of your inbox, Brandon, please.
For everyone. That's what you said now.
But guys, I have to get through these super chats. Then I'm going to look at your citation, Gleam, and then we'll give Jeremy a chance to say what he's been trying to say. which clock ticks faster, the stationary one or the moving one? We went through that one. JQ, $5. Thanks, JQ. 2 clocks, no twin brothers. Which clock ticks faster, the moving one or the stationary one? Yeah, I think we asked that one too. The point is, we can prove science, in quotation marks, the rumpist who will next argue that science doesn't prove things. Yep. Good point. JQ, no observers, just 2 clocks. Which ticks faster, stationary one or moving one?
Stationary always tick faster.
Stationary one ticks faster.
Yeah, but you must keep in mind that for the clock that is moving, when you view it as stationary, it also ticks faster.
We're not talking about viewing anything. We're talking about the physical clock.
Physical clock, yes. But it depends on frame of reference. If you're moving with the moving clock, it's stationary for you. Therefore, the other moving clock will be moving slower.
This is a mathematical construct. It's nonsense.
The moving clock is always slower. Double speak, I know.
Allow me to make one comment, y'all. Okay,
well, hold on. Let me finish through. No. Let me.
Go ahead.
Let me stick to the agenda for a minute. JQ, if you're a glober, you believe in time travel. That's what it sounds like to me. We don't. I'm using the term time travel. That's what most people call that kind of thing when you're jumping time. Essentially, you might want to call it something different. It is essentially time travel. Super looming hyena, $5. Brandon S. Rumpus. Sorry, I muted him already. If light travels 186,282, I think it's miles, in 1 second, how can you travel 50 light years in 1 second, which is 2.939 times 1,014 miles? How can you travel 50 years? I don't think we were doing the math correctly, right?
No, that's what I wanted to address earlier. No one's conflating distance with time. If Rumpus is saying we're doing 50 years, we're traveling 50 light years away and we're moving at nearly the speed of light, that's 50 years. No one's conflating distance with time or whatever you guys were saying 10 minutes ago where I was trying to get in. That didn't happen. I was going right with his scenario, and that's what we were talking about. So
no, I said that about them. That they're saying time moves differently if you the faster you go. So within their mathematics, those two are intertwined, right? If I go faster, time changes.
Yeah, but except when you're looking at the clock that's right in front of you, the time's not changing. It's ticking just like a regular clock would.
Yeah, no.
And if it takes you 50 years to travel, to that star and back, then 50 years is going to pass for you because you've been looking at the clock the whole time. So why would the fuck wouldn't you age if you've just been looking at a clock for 50 years?
Yeah, no, it doesn't make any sense. I think it's a mathematical
That's
thing.
beyond time.
No, they're saying the person on the Earth that wasn't watching the clock.
That's magical shit.
No, it was 50
it is.
If years on Earth. For you, it wasn't 50 years. It was 2 seconds. And you
No, I was looking at a clock the whole time.
And you didn't.
No, they're saying the person on Earth, Jeremy, the person on Earth was 2 seconds.
And you didn't travel 50 light years. You traveled 2 light seconds.
All right, whatever. Gleam, you wanted to show this.
Wait.
I don't think I can. I think Rumpus.
Yeah, can you just click on it just to show everyone that I haven't just made that bit up? Sorry, the actual link. It's just a wiki article on aberration, stellar aberration. I'm sure everyone's seen it and is aware of it, but I've just explained that exact thing to you. Taken a photograph, the moving frame is slightly ahead. Yeah, and if you can come down to that paragraph, it's the final paragraph on the introduction bit. Right the way down. I mean, Rumpus was saying there's completely nothing to do with it. Yeah, up a bit. Yeah, so aberration is historically significant because of its role in the development of the theories of light, electromagnetism, and ultimately the theory of special relativity. So God knows where it's got nothing to do with it. As first observed in the 1600s, searching for, I'm going to skip through bits, stellar parallax in order to confirm the heliocentric model of the solar system. However, it was not understood at the time to be a different phenomenon. In 1727, James Bradley provided a classical explanation for it in terms of a finite speed of light relative to the motion of the Earth in its orbit around the Sun, which he used to make one of his earliest measurements of the speed of light. However, Bradley's theory was incompatible with the 19th century theories of light. An aberration became a major motivation for the ether drag theories of Fresnel, Stokes, and Hendrik Lorentz. Ether theory of electromagnetism in 1892. The aberration of light, together with Lorentz's elaboration of Maxwell's electrodynamics, something I confirmed earlier, the moving magnet and conductor problem, the negative ether drift experiments, as well as the Fitzgerald experiment, led Albert Einstein to develop the theory of special relativity. So it was all from this, what I just explained. Trust me, boys. Right, forget about
Gleam
these
always brings,
white
What
talkers.
did you explain exactly?
Anybody questions Gleam, man? Gleam always brings citation. But let me put this
Hold on,
argument
I don't
in
think Gleam was done.
terms.
Were you in the middle of a sentence?
Yeah, no, that was it. It was just that what I just explained with the sun. I just tried to dumb it right down or be as layman as possible to explain.
I'm layman it even
Yeah,
more.
but that's
Dave.
not what this is
The
about.
Lorentz
Hold on, Jeremy.
transforms from that reference frame of Earth's photo to the reference frame of Sun's photo to get the right reference frame from God's point of view of what's actually
And now
happening.
let me dumb it down even more, y'all real quick. This is important to me. Okay, so they made their proof is the GPS. They had to change the GPS, right? Because it was off like just a millionth of a second and shit, you know, which was making a few meters difference and shit. Okay, so this whole thing started. The relativity started because they had to keep the Earth moving around the sun, okay, which is where the relativity started. Now, if your GPS, you're going to use that as proof. Now, ain't that coincidental that let me guess, the further the measurement with GPS, the more off it would be. So up on a flat Earth, okay, it's a different distance, okay, and on the globe, it's a little bit different, you know, and the further you go, it's a little bit more different. So it all ties into the math. So they're using the GPS time differential as proof. But because the Earth is not a fucking ball. Thank you.
If you look
Hey,
at Ron Hatch,
so to
Ron
go
Hatch
back-
is one that contends all of the GPS system, and it's more on the Lorentz absolute frame theory.
Glenn,
All
Glenn,
right.
do you
So-
do you believe GPS is based on satellites? I'm sorry, Jeremy. Go ahead.
No, I just want to point out how Chike gave the example just now of how it's 2 seconds for the person on Earth, right? That's the opposite of what they claim. They can't. They're just all over the place with this shit. It's bullshit.
No, I told you, you don't have the
And for the
proof.
person on Earth, it's like 2 seconds.
You don't know.
No, you didn't just say that.
No, for the
It
person
would have been clear
who
if I
went and came
got
back,
finished
it's 2
through with
seconds.
it. But now that it's
For the
5 minutes
person
later, I
who
don't.
went and came back, it's 2 seconds.
So it seems like 2 seconds to the person on Earth.
No, person of Earth, 50 years.
Right, but the person on this. All right, you know what? Never fucking mind. You're just.
No. You just had it backwards, Jeremy. He's saying 2 seconds for the guy in the ship, 50 years for the person on Earth.
I know, but two minutes ago, before Gleam started his citation or whatever, he said 2 seconds for the person on Earth. So,
Well,
but the guy on the
same difference though. What's your point?
No, the guy on the ship's looking at a clock. They're both looking at clocks. 50 years passes for both of them. Not 2 seconds for one If you could watch them, if the person on Earth could watch him the whole time, it would take 50 years. If the person on the ship could watch the person on Earth, it would still take 50 years because he's traveling for 50 years.
Amen to that.
So Jeremy,
I agree.
the-
Time does
in
not
their-
go
in their
differently.
head-
If you had a
in their head,
telescope,
they
you could
believe-
watch him the whole time. He's going to be gone for 50 years.
So
They're
they think
all
they're
looking
looking
at
into the
clocks.
past.
I mean, what the fuck,
Jeremy?
guys?
When they
Hey,
look
can
to
I
the
say a
stars,
word
they
in
think they
here,
look
guys?
into the past.
Yeah, no.
Jeremy,
Yes,
when
yes.
when,
I think
when
they're
they're
looking
looking
at
at the stars, really?
Yeah.
Hey, can I say a word, guys, please?
I'm fucking.
Who's that,
yes,
Essie?
I guess.
Yeah, hey, what's up, Brandon?
Hey, what's up, man?
Salute Montreal.
Go ahead.
Hey, Gleam. Man, guys, I am boiling right now. I'm steam is coming out of my ears. I had to park my car in the middle of what I'm doing so I can say this, man. I never heard a bigger pile of shit in my life, bro.
That's what I'm talking about.
What are you referring to?
Rumpus was saying we can travel 50 light.
Oh shit!
50 light years in 2 seconds.
You cut out there, bro. You cut out bad.
He was just warming up.
Hopefully
Maybe get
he's
to a better
pointing out.
spot, SE, or
Are you there?
Drop and rejoin or something. For some reason, it's cutting out. He dropped.
Hopefully he was getting to the point where Chike just literally said it's faster for the guy on the Earth 2 minutes ago, and then just a minute back said no, he travels 2 seconds if he's moving at the speed of light.
His
That's
clock is
faster.
faster.
Guys, sorry, I got cut off. Can we agree that time is a concept?
Yes.
Absolutely.
So all this time right now, you've been talking about bullshit, about a concept. About a concept taken and blended with a fabric, with space, made into space-time, and then we're getting to stretch it and bend it, and come on, guys, man. Seriously.
It's magical, bro.
Hold on. Just because something is a concept doesn't mean it's inherently wrong.
What?
Yes, it does. What are you talking? You think?
Well, the problem is when you say it's a concept, I see it as them or whoever the scientists trying to describe the things that happen in reality. So how else would we describe the passing of the time if not conceptually?
No, but what is time, Matrix? What is time?
Well, we've decided that the passing of the time, right? For example, when the show begun, that was an earlier time, and now will be at a later time, right? Just because we can grasp it or whatever doesn't mean it isn't something real, because we have to refer to it as something, right?
I think time would be classified as supernatural. It has no charge, spin, mass, momentum, like none of that stuff.
It's a concept, yeah. It's
a unit of measurement.
Man-made. Yeah. Well, here, if we want to get to the nitty-gritty, right? Time for man, right, is the revolution of the so-called Earth, the movement of the sun, the moon around. That's a month. But when it comes down to the basics, it's movement, right? It's based on the movement of a cesium atom, correct? So it's based on movement, right?
Yep. The vibrational frequency of cesium.
The measurement, Gleam, the measurement is the convention of time. I think SE's talking about like actual, like the passage of time, like time, you know, like not. I don't know how to explain it.
There's no substance that you can't pick time up. There's no substance of time, right? It is just
no, just like there's no substance of centimeter or kilogram.
Like love. What's love, right? It's a concept, right? That's what time is.
Yeah, but I wouldn't say it's not real. You know, it is experience, right?
It's an apportion that we give to it. It's a unit.
What you're thinking of experience, Brandon, is you're thinking of our life cycle, which I can explain in a number of heartbeats, for example. Brandon has 3,000 million heartbeats, whatever, and then it's game over.
Wouldn't that be just another measure of
time, right?
The sequence of event? I mean, yeah, I guess we're saying the same thing, probably a little differently.
Okay, now why I'm saying this, right? Because we got to tie it to motion, right? Now, back to time dilation. They took a concept of time, they took space, they made it into a fabric, and they tell us that it stretches, right? That's what they tell us.
Right.
With all this Lorentz control.
Yeah.
He got out again.
Damn, he did. Yep.
But I like to think of it as like there's a convention of time, and there's something that's happening in reality where events.
You're gonna see where I'm.
Oh, go ahead. Go ahead. You cut out. Go ahead, Essie.
Okay, if we can agree that we can count time with an hourglass, sand, right? One bead is a second, right? That's time.
That's the convention of time.
Right.
Like the centimeter. Go ahead.
Okay, so our idea of time. They tell us. I'm cutting off. Damn, I'm in my.
Yeah, you keep cutting out.
I'll try to my finger. So where I'm getting at is this: if time is motion, right, and we can measure time with a sand clock, right, an hourglass, right.
Yep.
Now they tell us time dilation is with gravity and with speed, right? So on the person on the ground and the person in space, right? We're going to fantasy now, the astronaut, right? He ages slower, right? So his time.
Oh, you cut out again, Essie.
Yeah.
Fudge, man. I guess we're gonna have to do this another time, man.
Well, we'll give you some time next time you're on to talk about it if you remember, or if you get to a better place in the next 15 minutes.
Okay, I'm sorry, man. I didn't want to spoil the show. We'll do it another
You ruined
time.
the whole show, bro.
No,
sorry, guys.
The whole show.
It's cool. It's worth a try. I appreciate you trying.
All right.
Another super chat. Dan Morris. Rumpus managed to waste a ton of showtime and got the whole room arguing. Indeed. I'm sure his handlers will grant him a gold star for the day's work. He is a specialist at doing that. Yeah, that's why I mute him after a certain amount of time. But it is what it is. Okay. Did we get to the bottom?
Can I try and even simplify it even further on the Lorentz transform specifically, without going into the depths of space-time and Minkowski bending off? But if you imagine your standard coordinates A, B, and C, yeah, all the Lorentz transforms are A, B, and C equals A prime, which is a little 1, as if it's the power of, B prime, C prime. And all that is basically saying there is a distance between the observer and the event happening, let's say. And the observer witnessing that event cannot be seen as absolute time, because it's irrational. Einstein said, and rightly so, it's irrational to think that there is just one time happening, whereas the same clock on that sun should be ticking the same amount of seconds. It's just that the time that I'm capturing them at is a different time frame to what someone else would be looking from a third person. So you use that ABC to A prime, B prime, C prime to transform between the two reference frames. And it's got nothing to do with logic or anything like that. It's just basically saying, right, from here to the sun, there's 8 minutes. So I now need to transform everything from 8 minutes difference between the two.
Again,
Look,
you're just
Glenn,
talking
this
about
is the
the travel of light and viewing it from different viewpoints. I'm totally cool with that. That's not magic. That's not what I was calling magic.
Yeah, that is the basis of it. It is a lot more complex than that.
It's not. You don't.
I've just read out that it is,
Chike.
Chike.
You don't
All right,
understand.
here's the question. Did
That's what you say.
did the
It's
light
not
from the
how
sun
you
took
measure
8 minutes
stuff.
to get? Chike, let me ask you. Did the light from the sun took 8 minutes to get to us?
Yes.
All right, then there you go. You're just fucking contradicting yourself.
No, I'm not. Because you don't
Yes,
understand. No.
If you
Can you
put
load up the
if you put
Lorentz
a clock,
transform
hold
wiki
on.
page, Brendan?
If you put a clock on the photon that is leaving the sun, right, towards us, and that photon is gonna take 8 minutes to get to us.
No.
It's 8 minutes.
It doesn't.
You just said
yes. The photon take no time to get to us. No, it
Transformation.
covers any distance. The photon is created and destroyed at the same location. As far as the photon
First set of sums.
concerned, there was no time.
If you see there, that's exactly what I just said, but without the time. Time prime.
So if you had a clock.
See, my first question was, the first question was, did it for that light? Did it took 8 minutes to get to us? And you answered yes, and then you
No,
change it to say it didn't take any
us,
time.
for us,
Yes,
it,
and then
it,
you
it,
have a
it
clock on the,
for
and then
us,
pretend
it
you have a
took
clock
the
on the photon.
to travel 8 minutes.
Why
not for the
would it take
photon.
8 minutes if it's
Not
getting
for
to
the
us instant?
not for the photon.
Hold on. If it's getting to us in an instant, what it would take 8 minutes? Why would you say that?
For us, because we are not
Yeah,
a
why
photon.
would you say that?
We
If
don't
the light
travel
took
the speed of
0
light.
seconds.
We don't travel through space at the speed of light.
So you're saying that for the
regardless.
photon it's instantaneous, and for us it's 8 minutes? Is that what you're saying?
Yes. Yes.
So if you had a clock on the photon, the clock wouldn't tick, even though it just traveled 8 minutes.
No, 0 all the time.
Even though it just traveled 8 minutes, the clock. There's some kind of
It
mechanism
didn't travel
that's
8
make
minutes.
the clock.
It traveled 0
There's
minutes.
some kind of mechanism inside the clock, or something's making the clock not tick for 8 minutes.
Can I ask a question? What is this hypothetical clock made of? Is it a digital clock or some sort of mechanical clock?
Mechanical clock.
Hypothetical clock.
All right, but if it's a
mechanical clock.
If it's a mechanical clock, I think I might be able to provide some sort of explanation of it. Mechanical clocks are made out of some sort of metal, right? Is it possible that the reason that they are changing is because of the temperatures of wherever they take it? For example, metal parts will react different when in the cold.
By temperature, bro.
What was that?
Our hypothetical clock is not affected by temperature.
I mean, I'm just saying, in a real clock, if it's made out of metal and you take it to the cold, wouldn't it slow down all the metal, theoretically slowing down the gears and slowing down supposedly time itself?
It's an ideal clock. It only shows the time. That's all it does.
Okay, there's a clock on this photon. It just traveled for 8 minutes, riding this photon all the way to Earth, but the clock didn't tick. Why? How? What made the clock not tick?
The nature of photons traveling the speed
No,
of
there's
light.
no fucking photons, bro. It's a mechanical clock. Secondhand shit. What
You
the fuck are you talking about photons for?
He's chatting shit. Read what's on the screen, and he's just said it's a complete misunderstanding. And if you read just underneath the equation there, or the transformation, it says exactly what it is.
What
T,
mechanism?
X, Y, Z,
I see
and T
T.
prime.
I see T in the transformation. Without the T,
There has to be a mechanism that makes this clock travel for 8 minutes and not tick. What's the mechanism? Some kind of physical process.
Well, it's an ideal clock, no physical processes, right? Only show the time.
Oh my god!
Hey,
fucking worthless.
Gleam, same
That
question
shit.
that Jeremy asked to you. The clock on the photon. It
wouldn't do that in my eyes.
Would it show 8 minutes if we started it off at midnight? When it got to us, would the clock show 8 minutes?
8 minutes.
Okay.
Traveling at the speed of light.
Do you think these
Then
guys
why
are
would the clock
misunderstanding?
on the
Do you think these
Hold on,
guys
the
are
clock-
misunderstanding this whole thing when they're talking about
No,
the time
maybe
travel? and
I'm
shit?
open to the fact that I could be misunderstanding it, but I just hear a load of contradiction and a load of gargled mess and ideal clocks and madness. Yeah. Instead of realistic, I've always tried to dumb it down and explain it from the simplest form instead of diving straight into this is how you explain it complexly and everyone's going to understand. If you're not, you're stupid.
Yeah, because it cannot be explained at the simplest form.
It can be.
It's not something you can explain simply.
So you have to take it on faith.
There's a damn wiki page on it, mate.
You have to take it on faith, Chucky.
And the evidence is that you don't understand what you read.
Chucky, do you just have to take it on faith that it's true, or what?
Hello?
No, I gave you an example. And I wanted to tell me what do you think is the time on the clock on the sheet that sees the same event?
Let me ask you.
From Earth, we see it at 300,000 kilometers a minute after, a second after. What does the ship see? We see the ship 3,000 kilometers. So the photon cannot be traveling more than 3,000 kilometers in the sheet frame of reference, could it?
See, now you're talking about what we see. Again, you're talking about what we see. That's why we went to the clock. The physical clock has 8 minutes on it. Now, the clock on the ship, Chaiki, hear me out. The clock on the ship, when that photon is physically at the sun and travels to the Earth 8 minutes away, if they knew that at that time, when that photon left and when that photon arrived, the clock on the ship would show 8 minutes. Now, they might see something different, but it is 8 minutes. It's going to take 8 minutes no matter where you fucking are.
No.
Yeah. That's reality, dude.
It's not.
I'd like to say something.
So the speed of light is not the same in all directions.
I've seen globers who believe in the globe, who believe in relativity, having similar discussion like this, fighting with each other. So, as someone said, I can't remember who, maybe we don't understand what the theory is trying to say, and we're just arguing without, full understanding.
There ain't nothing to argue about. You guys are fucking Doc Watt. The Globers are Doc Watson and Michael J. Fox talking about 1.21 gigawatts, and here we are in reality saying you're talking word salad and just making shit up.
Bro,
what I'm saying is
if you got a no result on an interferometer,
this isn't an
no result on an interferometer, you have to have an explanation, bro. And then if your GPS didn't match the globe, it was off by milliseconds. Okay, the further you got, the more little milliseconds it's off because the ground is curving. You'd have to stick to that bullshit, man. It's obvious bullshittery, man. It's to keep.
I guess no one got what I'm trying to say.
They gotta maintain
you didn't get what I'm. You didn't get what I'm trying to say. I'm saying that. My point is, globers who believe in relativity would argue among each others like this. So relativity is very complicated.
It could be just either side.
And regarding
that, there is a misunderstanding, even on the globe side, or a disagreement on what all this means.
Yeah, that's what I mean.
Even on that side, this isn't a globe versus flat Earth thing strictly.
Yeah, and regarding the GPS satellites, it's a practical application, but it's not the experiment. Because there was an experiment, I think, in Jumbo, Boeing 747, traveling around the world or something like that.
Of course, they're going to do experiments to back their bullshit up. But Einstein admitted before he died that the relativity was a direct response to Michelson's null result. Okay, it's no story. We know where it was born, and we know why it was adjusted, and we know that they always got to come up with these experiments with bullshit factors, bullshit variables. One variable and say, oh, that proves it. They try and try and try. They finally get something that obeys with their bullshit. But to me, it's all fits back to practical reality. It's easily explained with common sense.
This is the equivalent of arguing over the chemical compound of the silk Spider-Man shoots out of his fucking wrist.
Exactly.
Pretty much.
And you know what? There's no point in telling you about an experiment that proves time dilation unless you are witnessing the experiment and you know everything, every detail about it.
Now wait a minute. Spider-Man does not shoot that out of his wrists, okay?
I don't know.
He created a device that allows him to shoot the material from the area around his wrist, but it's a machine. Jeremy!
Hold on. Correction. It depends on what universe it is. Because in some universes, he does shoot the thing from his arm.
Yeah.
From his hand.
What about Venom? Venom. He can shoot stuff out of his body. Didn't think of that, did you?
Venom could shoot his entire body, actually.
Venom's a whole different ballgame.
He shoots his entire body out of his body?
Yeah, dude, he could literally project himself out of any host and jump into somebody's body.
I like how the conversation can shift from special relativity to Marvel and it not sound any difference. No, it's good.
Yeah, exactly.
It's all relative.
It's the same fantasy.
It's because it's all made up nonsense. It's pretend land.
Exactly, Chaiki McFly.
Well,
we
I
can
don't
do
think
spaghetti. You guys know how the old saying goes, right? Whatever happens in Narnia stays in Narnia, right?
Yeah. All right. Well, that was good. That was a good conversation.
Albert Einstein and Stan Lee might as well be the same guy.
Could be, although I do prefer the work of Stan Lee, to be honest with you.
Yeah, at least he'll admit that it's pretend.
Yeah, right. Well, I mean, maybe mathematically it makes sense, you know, within the construct that they have, and maybe it does work for GPS, but the idea that shit is actually time traveling, like the explanation of the ship going off and coming back and 50 years having elapsed for one thing and 0 or 2 seconds for the other thing.
That's nonsense. That's nonsense.
Yeah,
Absolute nonsense.
Total nonsense.
The math demands it. The math demands that, and black holes. The math demands that kind of shit.
If the math demands time travel, then you got a real fucking problem.
No, it's the opposite. The math of relativity cannot explain the severities of a black hole. That's where it breaks down. That's where relativity stops working.
Yeah, information, but it predicts the fucking the black holes, but the information is where they're all boggled. Because if all this shit were true, they could just take and they could just marry some particles, okay, and send them around the accelerator and keep sending a message. They could use Morse code, and they could just keep sending around, and it will be going back in time basically. And they could send themselves a simple type of Morse code just by making the adjoining particles. What do you call the particles that are like coupled?
Entangled.
Yeah, entangled. Yeah, they could just do a simple Morse code and make one of them, when you open the box, blue, one of them red. Because we know that if we can force it, if one of them's red, the other one's going to be red. We could do a simple Morse code and then send ourselves messages until we could get it more and more complicated, like the dude on the mission to Mars bullshit, where you start with something simple, but they can't send information. It's all a crock of shit, man.
You think that's what they're trying to do, Brian? Is send fucking messages back to themselves?
Yeah, I guarantee you that's what they were trying to do, man. But it's going to fail, just like fusion's going to fail. It's plasma based. They're going to fail with fusion. That's where their shit's been stuck. They got all these smart minds looking up in the stars in La La Land and working at CERN and looking for gravity waves. That's where they got all our brightest minds. They should be working on not fucking burning gasoline and bullshit and depending on fucking burning coal and fracking and all this shit, dude. Everything is so fucked up, and it's so obvious to me, man.
Huh. It's an interesting argument to be made there, especially when, just as we discussed earlier, this detecting gravitational waves will really lead to no, practical application that we could foresee.
It's going to push us. That's going to technologically push us ahead by leaps and bounds. I mean, this is bigger than the internet. Gravitational waves. Just think of what you could do with that.
Anyway,
Councils could cover
just imagine if they could prove with a gravitational wave detector what they actually been talking about, right?
Bro, we're still getting flat tires on the side of the fucking road.
They're actually working on that. They're coming up with the airless tire. I don't know if you've seen that or not, but that's going to be big.
And LIGO is definitely central to that effort. That's what I reckon.
I think they should fill all potholes with black holes, and then everyone will avoid them.
And if you think about their dark matter, that is considering all the quasars. So they're assuming all these quasars, all these black holes. They're counting that as matter. So just their theoretical shit way outweighs the actual matter in their fucking paradigm. And then they're still missing 95%, even with all this fantastical shit. So they say they're off 95%. I say they're off 99.9%.
William, what's your thoughts? What's your thoughts on the problem with the fact that there's too much gold? Does your electric universe take care of that gold problem? I'm guessing it does.
No, see, I don't know what you're on about. Too much gold. I thought there was only an Olympic swimming pool size worth of gold in the whole entire Earth.
That we've mined a couple Olympic swimming pools. Yeah, there's way too much though, and it's a real problem in
Who made that claim?
Modern. That's a real problem in modern.
I doubt that very much. I doubt that very much.
That's an actual problem in modern.
Guys, how can people make those claims?
Well, it has
Jeremy?
to come from space on the globe model, definitely. It wasn't naturally produced in the Earth.
Yeah, no, it's an. I thought your electric universe would take care of it because we
Or
can
it's just
turn
a pretend problem because
murder.
somebody wants to make the price of gold go way up.
Well, no, the problem is
It's a very valid
problem
point.
is that there's too much gold. They're saying there's too much gold for the heliocentric model. Do a quick Google search on it.
I found it.
Yeah,
Listen to this
like a
headline.
mainstream problem.
Yeah,
Listen to this headline.
transmutation and whatnot. They say in the electric universe model. So, but yeah, I wouldn't be able to explain anything to do with that. No one knows where any gold come from. I would assume.
Yeah,
it's all.
Well, they think they know though. The quasars and.
Listen,
like that.
There's a crazy
listen to this
guy.
headline,
There's a crazy
though,
guy
guys.
claiming that.
Well, listen, guys.
Listen to this headline, guys.
Asteroid hit and it killed off all the unicorns. They died and their bodies were absorbed by the ground and got compressed into gold.
All right, I'll buy it.
Obviously.
There's too much gold in the universe. No one knows where it came from. Something is showering gold across the universe, but no one knows what it is. Can you guess what website this is on? Anybody?
Life Science, it says at the top.
Yeah, Life Science. You guys, I thought somebody would know right off the bat that it's Life Science. Something is raining gold across the universe. Oh boy, just total comic book.
It's raining gold.
The point is, it doesn't fit their model because in their model they know where gold comes from. It comes from when a sun explodes or a supernova's fucking collide.
Doesn't it rain diamonds on the planet though?
That's true. I guess if you got it raining diamonds, anything can happen.
Yeah,
it's also time travel.
Planet supposedly goes nova when it reaches iron, and that's not
When
even
you're
halfway
dealing-
density in the periodic table. I mean, so
When you're dealing with raining diamonds and time travel. Oh, my bad, Brian. Go ahead. I thought you were done.
No, you're good, bro. You're good, bro.
Diamond rain falls on Saturn and Jupiter. Both planets. I didn't hear both planets. I didn't know it was both of them. Shit.
If you go back as well, there's two other planets that it says as well.
I mean, when you're
God,
dealing with shit like time traveling and diamonds raining on planets, like there's nothing
Neptune
you can't
and
make up
Uranus,
at that point.
Neptune also.
Hey, we'll end it on
Uranus.
this, man. We can end it on this. Dude made a good point in a debate. He's like, so he looks up why they say that stars are shimmering. You know, why is it shimmering? Because of the atmosphere, because it cutting through the atmosphere, we get the twinkle. Okay. Then why ain't Jupiter or Mars shimmering? You know what I'm saying? That was a hell of a good question. It's just all these questions that we need to think of. They're outside the box. One, they can't Google search, and just listen to them. Just blurt whatever out that'll fit their model. They will say it as a fact before they even know. They'll say it like it's a fact, just because they're so certain their model's true. I don't know.
You're even like both.
The stars.
Have you guys
stars
noticed that
would
they
be
become experts over a minute? Like when we're asking questions, they become experts.
100%. And as soon as we start asking for definitions, all of a sudden in Google, the definition starts changing and it starts reflecting what they're saying, kind of thing.
Let me address the star twinkle thing. And in their model, you're looking 400 light years or some shit, the Polaris. There must be so much. If you had a little speck of dust 300 light years away, you wouldn't even be able to see Polaris. If there was just a tiny speck of dust in there, because of the angular size would block it out due to perspective. So, like, you should never see any of the stars if they're light years away, and there's all kinds of meteorites. You know how many meteorites Earth gets hit by a year? There's tons of shit up there. You should never be able to see anything. Anything.
Good point.
Oh,
Good point.
That's a problem, Jeremy. Like even on the flat earthers, there's a problem when you say that you can measure distances. I mean the speed of light and stuff like that. That when we don't even know what it is, or like.
Yeah.
No, I'm not talking about measuring the speed of light. I'm just saying they claim that it's 400 light years away or whatever. And if there was a piece of dust or a tiny meteorite in between there, you wouldn't be able to see that shit. You shouldn't see any stars.
Yes, but it doesn't stay there.
The consequence of that statement is that that light is traveling through so many light years of distance, right? And like at this point, you're falling into their story.
No, I totally get you on that, Silent Zero,
Jeremy.
because you do bring that up a lot, and I know it bothers you that we argue within their framework. It's just like trying to explore and kind of expose people to the underlying logic and reasons these guys say some of this stuff and the absurdity of it all. That's the way I see it. Like time travel. We explored these ideas of relativity, and we get to the point where we're arguing over whether time travel is real or not.
Yeah, and I'm not going to shut down. Look, I know the shutdown arguments, man, but I'm not going to shut down.
It doesn't bother me, Brandon. Actually, I actually like it. I actually like that we can hear how ridiculous these people are, right? I like it, but I always like to point that out so that we don't forget that we're just arguing from their so-called story.
Yeah, but not to mention, dude, not to mention, I'm open. Hey, if they ever give me evidence that's solid and 100%, I'm not going to marry myself 100% to nothing. To nothing at all. Not flat earth, not anything, but I'm most certainly not a fucking spinning ball through the way they describe it. But I want to hear the debate. I want to hear their arguments. And if it wasn't for us listening to them, and we got our own ways of shutting them down. I know the shutdown arguments to just squash the debate before it happens. We realize they beg the question about every proof that they have. There's not one proof without begging the question. They try and use even like we're entertaining moon bounce, all that shit. We entertain that with look. There's a medium, and what do you know? 6 months later, they come out with an article that the atmosphere extends out past the moon. They're having to change their shit due to our arguments and begging their questions.
That's what I was talking about. That's this kind of thing I was talking about, Brian. That it seems that somebody is paying attention, right? There's somebody that's listening to these debates that's adjusting these Google and these wiki pages. I mean, it's real. When you start to think about it, it's really nefarious.
If we didn't let them beg the question and get away with all their fallacious bullshit, there'd be nothing to talk about.
Well,
the problem is it's all fallacious, Jeremy. It's all fallacious, and it's all begging the question, and it's all an appeal to authority.
Sure.
You can't get behind that.
Guys, at one
Jeremy,
point,
I'm trying
Rumpus
to
described.
Come on, Rumpus.
Nobody cares.
I don't care about. I want to answer to Jeremy.
At one point,
Jeremy,
they described what we see on.
Strike, you're next.
Yeah, at one point, Rumpus described literally what we see on the Star Wars movies when they're traveling, like they're gonna go into hyperspace. The lights coming to you. He described exactly that. It was amazing.
No. The movie describes what Trumpus was trying to say.
So, Jeremy, you said that if there was the Earth atmosphere reach forever and we shouldn't see Polaris, for example, but we know that stars that go down to the horizon will be difficult, if not impossible, to see.
Is there a point where Earth's atmosphere stops? That's your guys' claim.
So at this point, when we can't see them, how much atmosphere do we look through? About 200, 300 miles, maybe.
So after 300 miles is where Earth's atmosphere stops. Because I've been desperately looking for an answer to that question. When does the gas stop?
Wait, let me try the logic. So if I can't see them through 300 miles of atmosphere, and I can see them when they are straight above me, I suspect that between me and the star.
You're not going to answer my question. I feel like you're not going to answer my question.
I got a good one, dude. I got a good one.
When does the atmosphere stop, Mike?
But why can't I finish?
No, because I asked you a question.
My logic tells me that there's less gas between me and the stars than between me and the star when I can't see him on Earth when it's on the horizon.
Okay.
That's
not less, Dikey.
Hold on, Brian.
Not go to some citation that Earth atmosphere goes forever or
Brian.
reach the moon, and I try to say how much.
Yeah,
of
let me
Hold
ask.
on, anyways. He's
and
waffling
it's
on about
like they
nonsense. He's not
said,
going to answer my question.
fuck
Classic
all.
Glover
There's
strategy.
nothing
No, he's not.
there.
Let me give him a practical
There's
example.
an
Chikey.
item
Yeah,
there.
go ahead.
Nobody sees
Chikey,
it.
we understand that argument, Chikey. But look, when we put balloon in liquid nitrogen and it deflates, if you open up that balloon, air don't go rushing in there, bud. Okay? It stays deflated, okay, until it warms up and inflates the balloon. There's no fucking vacuum up there. It's just colder, dude. It's just colder. Like I said, you put a balloon in liquid nitrogen, it shrivels up down to nothing. It deflates. But like I said, if you open that balloon up, air does not go rushing the fuck in there because there's already, the air is there.
Because
It's
the
just
pressure
cold,
is
bro. It's just
equalized.
cold. It's all
It's
all
equalized.
equilibrium, bro. It's all equilibrium.
It's equalized. However, if it wasn't a rubber balloon, if it was a glass balloon, and you freeze it and you open it, the air would rush in. What's wrong with
Okay.
you, Brian?
So, where?
No, it
what's your
wouldn't,
point?
because
Is-
the
what is your
temperature
thing
would
on what-
change. There'd be there'd
Yeah,
be something else besides
also,
entropy. The only thing that changes is entropy, Chikey. The only change is entropy. Okay? If it expanded into nothing, into an infinite vacuum, then there. Oh my god, dude.
Brian.
We've showed you that the only thing that changes is entropy, bro. It's easily demonstrated with.
All right, guys, I'm going to wrap it up. We obviously solved all the world's problems tonight, and should be on the cover of many science magazines tomorrow morning. So look for those issues, save them. They'll be worth a lot of money in a few years. And we'll be back tomorrow for Friday Night Fights, which I feel like we've had fight night pretty much every night. Been a lot of rumpus this week, which is not always a bad thing, but tomorrow I'll have to really let him off of his chain. It was a good discussion tonight at some points. I'm trying to get an understanding of what the heck they're talking about with this special relativity, I guess it is. And the whole time travel issue. It's hard for me to believe that they actually think this. It seems like it's got to be some misunderstanding on my part of what the theory is, but I don't know. We'll see. Anyway, thank you for listening, and shout out to everybody who supported the channel tonight. Special shout out to JQ who sent in a lot of super chats. Thanks, guys. And thanks to the channel members and the mods and everyone who listened. And thanks to the panel members who joined the show. Much appreciated. We'll see you guys tomorrow. Should be fun. And have a good night.